Uno, dos, tres. Uno, dos, tres. Sí.
We're in the beautiful city of Cartagena, the Indias. We're greeting all of those who are connected through the Colombiamar link. And at this point, I invite you to share your participation in this Colombiamar 2021 event. We start with Colombiamar 2021, which is an event of design enable engineering to promote the naval, maritime, and river industries through academic and scientific, technological, as well as commercial experiences, so that your companies can transfer innovation, knowledge, technological breakthroughs of this industry. This year, given the restrictions established by control entities in Colombia and the personal care in terms of social distancing in the midst of the pandemic, we decided to do this event on a digital platform. We want to thank our sponsors for assisting us and for being part of this version of Colombiamar 2021. We welcome the commander of the Naval Forces of the Caribbean, Rear Admiral Juan Ricardo Rosso Obregón, the President of COTECMAR, Luis Fernando Márquez Velosa, and Ms. Amar Sepúlveda, Vice Chancellor of Research and Innovation at Universidad Simón Bolívar. As follows, we are going to hear the welcoming words by the President of the Republic, Iván Duque Márquez. Science and technology for the development of the maritime and naval industries, and all attendees to COLOMBIAMAR Digital 2021. Within the framework of this event, we also carry out the Naval Design and Engineering event, which is the main scientific and innovation program in the shipyard industry with the participation of stakeholders from the naval, maritime, and river industries of Colombia and the continent. As you know, this industry has a special place in my heart. I got to know it through my father, and I learned of its potential to generate development. I would like to highlight Cotecmar's growth throughout my years of administration by becoming the epicenter of the shipyard industry in the region. I would like to highlight the defense aid boat as well as two maritime interdiction boats that were added to the coastal trade operations of Cotecmar, which was sold back in 2017. I would also like to highlight the vocation of service of the company in terms of the overhauling and shipbuilding efforts of flagships to different countries, including Asia. I'd like to commend your participation in this event, which will generate different initiatives and business deals leading to sustained growth for our territories. I can assure you that from the national government, we'll continue to work hand in hand with Cotecmar in order to take full advantage of the shipyard industry and continue building a great future for all. Thank you. Okay, thank you, Mr. President. We want to continue with the words of the Colombian Minister of Defense, Diego Molano Aponte. This context of discussion about the future of the naval design and construction is important for this time of economic reactivation. The shipyard industry engages the action of several economic sectors that integrate the products and inputs towards the development of technological capacities in the promotion of a vital sector within any nation's economy, such as the naval, maritime, and river industries. As a matter of fact, it has a multiplying factor of up to two times the money invested into it. The development of the shipyard industry also implies a projection towards the future of a new capacity that Colombia is currently developing through Cotecmar and the Bioceanic Compass, where we find a great deal of capacity for innovation, technology, and generation of jobs, which links to recent laws such as a law where all flagships and maritime devices have better availability in Colombia. That's one of the discussions that we have rolled out within this important forum. Colombia finds in Cotecmar the cornerstone of the shipyard development through the design of vessels and the construction of navy capacities, which spills over to other sectors, is actually developing different capacities and strengthening the strategic capabilities of our Navy. We want to share our experiences with different nations and essential stakeholders in the maritime and shipyard industry, which is vital for this reactivation process that Colombia has been addressing in the past few years. We want to immensely thank you for the invitation, and we want to wish you every success in this exchange of knowledge and information. And we wish you every success in the development of this important academic event that you have organized. Thank you so much, Minister. And at this point, we welcome Ship Captain Miguel Andrés Danica, Chairman of the 7th International Congress of Naval Construction and Design. He is a PhD in electronic engineering and electronic Power and Control Systems from Universidad Politécnica de Catalunya. Masters in Electronic Engineering and Instrumentation, as well as Communication from Universidad de Barcelona. A specialist in National Security and Defense from General Rafael Reyes Prieto Combat University. He has a specialty in electronics from the Almirante Padilla School for Cadets. He has published in different international publications in electronic and electrical engineering, as well as industrial and power engineering. He is part of the Excellence Center as an associate researcher. He has developed positions as the director of the Scientific Research Center for the Almirante Cadilla School for Cadets, and currently he is running the path of science, technology, and innovation for the Colombian Navy. Captain Garnica, welcome.
Buenos días a todos.
Good morning, everyone. Welcome to this first day of the International Conference of Naval Design and Engineering, CDIN 2021. To kick off the program, I would like to invite as a keynote speaker, Dr. Donato Martinez Perez de Rojas, Director of Technology and Digital Transformation and the corporate head of Navantia, who will talk to us about an important topic, digital transformation in the naval sector. Dr. Martinez, born in Santa Cruz de Tenerife, Spain, is a naval engineer from Escuela Técnica de Ingenieros Navales in Madrid. He has a master's in business administration from the Higher Educational Institute in the School of Directors at the Industrial Organization Academy. His professional trajectory has been developed mainly at Navantia, where he started at the Scorpen program for the Chilean Navy as an attaché for the technical director in Madrid. After several positions within the Scorpen consortium in the fields of quality and technical development, in 2006 he moved to Madrid for the development of programs within the technical directorate. He was appointed manager of the S-80 submarine program for the Spanish Navy. He participated in the creation of the Navantia Operational Center in Australia, where he successfully directed the activities of the SEA 5000 program for the future frigates in Australia and the reform of the AWD destroyer program as the director of planning and production engineering. In June 2017, he was appointed as the director of Navantia in Australia. After that, he went back to Navantia in Spain, and in late 2019, he was appointed the director of technology and digital transformation, which is his current position. I now give you Dr. Donato Martinez.
Esto que nos apasiona ha sido el motor desde hace más de 2 décadas.
This passion has been our engine for over 2 decades, thanks to the strategic vision of the Colombian Navy, with the creation of COTECMAR as a main support for the evolution of capacities through engineering, design, construction, and maintenance of the Colombian Navy fleet. From our privileged geographic position along the warm waters of the Colombian Caribbean in Cartagena de Indias, we work day in and day out expanding our offer to the international market. Thanks to the capacities and experience acquired throughout these years, we have been taking on ever more challenging work by giving the best of us with the support of our human talent. During all of this time, we have maintained ourselves as a leader in terms of science, technology, and innovation nationwide by leading sector-based projects within the shipyard industry by means of knowledge management and the execution of innovative projects as part of our corporate DNA and culture. This has allowed us to develop our productive capacity by providing solutions with high quality standards. We have some of the largest and most productive offices in the region through the production of over 200 innovative products, as well as an extended reality lab that's allowed us to ensure every step and every detail throughout the ship design development. We have materialized the dreams of our customers by adjusting to their needs through the construction of defense vessels, commercial vessels, as well as technological solutions, including social benefits. We believe that a vessel should always operate efficiently and safely, and that is our commitment to our customers and their fleet. Through operations in repair, maintenance, and overhauling, we guarantee safe, efficient, and transparent work. We receive larger ships, both domestic and international, for afloat and dry dock work by means of our synchro lift, which allows for a fabulous tool at the heart of our Mamonal plant. On the other side, at the Cartagena Bay, in our Boca Grande plant, we have a slipway system to offer maintenance and overhauling solutions to the Colombian Navy as well as commercial vessels. All of this installed capacity and the expertise in the shipyard industry also allows us to offer customized solutions in the industry, which has helped us become a key stakeholder that provides industrial solutions in Colombia. We keep on pushing forward and generating jobs, generating productive projects and high added value developments that has consolidated us as leaders of the naval, maritime, and river industry in Latin America. At COTEMAR, we keep going forward. Dear attendees of COTECMAR's 7th sitting, I now give you Dr. Donato Martinez. Welcome, Dr. Martinez. The floor is yours. Very well. Thank you so much, everyone, and thank you for having invited me to share with all of you Avantia's vision in the digital transformation of the naval sector. I will be sharing my presentation with you at this point. Okay, I hope you can now visualize my presentation. The content of the presentation I'm going to be doing revolves around these points. A brief introduction where I will share what Navantia is and who we are. The second point, which is summarized, is the naval construction process so that we understand how we focused on the naval development in Spain. Then some lessons learned that I will try to share with you, especially for those who are starting with the innovation process so that you don't make the kind of mistakes that we've made in the past in the midst of this process. Okay, Navantia, as you know, is mainly based in Spain, although we also have some facilities and affiliated headquarters in other countries. So we have presence in over 20 nations of the world. In Spain, we are based in Madrid and we have shipyard and reaper facilities and engine construction and complex system construction facilities in the sites that you see on the screen, Ferrol up north, down south also in San Fernando and Rota, as well as Cartagena. At this point, after the installation of our strategic plan, there are 4,000 professionals of us, and we have the support of external collaborators, basically adding an extra 8,000 people. All of these human capital resources you can now see on the screen. The entirety of the company is devoted to new construction and the manufacture of propulsion systems, and the rest of the company is devoted to propulsion and other systems in our main headquarters. The group has other facilities on the screen, which I am not going to dwell upon. As for services, we have defense vessel products, which is the core of our company. We also have combat systems, platform control communication systems, navigation systems, engines and turbines. We are maximizing the use of our headquarters and we're diversifying to green technologies, mainly wind offshore. We're very strong in repair and construction and support to a life cycle as part of the services that we provide to our customers. Okay, I would like to highlight the strengths on the screen. Basically, the four listed, we are a strategic company for national defense, both for Spain as well as allied nations. We are a company that generates knowledge and as well as technological developments. We are very focused on high technology products as part of a highly connected company. We have a clear vocation of exportation to be able to balance out our portfolio, both domestically and internationally. Today present an essential part of our company and the vision that all companies have aims at sustainable development. That's why Navantia, as well as many of your companies and organizations, is devoted to the 2030 agenda to accomplish for the world to become ever greener and so that we can recover the habitat that we had a few years back. So how have we developed? As a summary, for about 50 years now, the company has focused strongly on vessel construction, revolving around design from foreign companies, and gradually we have been developing engineering capacities within our company so that we can roll out products co-designed with foreign companies as well as designing products within our own company. Based on that, for 20 years now, we've exporting designs from Navantia to overseas companies. This is the whole learning cycle within the naval realm. It is important to highlight the value of naval construction, and particularly military construction. This is the complexity of the products that we've developed, not only in Avantia, but also for all of us who are in the Navy design sector. And here we can compare different types of products with a high technical complexity within the defense sector, both in terms of the number of items on board as well as the hours of design and construction. There is no comparison to other types of products in the industrial sector. These are the figures that we manage in Avantia. Our biggest focus is on technological development so that we can maintain a level of competitiveness and appeal in terms of our products for more sophisticated customers. This is the track record that we have at Navantia for the past few years with over 10,000 million euro or 10 billion euro of exports to different countries. This is the process, the way that we develop through the Spanish Defense Ministry. The products are reflected by different conceptual stages in terms of service, and Navantia, within its role of design authority, what it does is to provide assistance in the definition of customer requirements with a series of engineering stages where we detail the different product alternatives fulfilling the customer's requirements, and it converges in a with the shape of a funnel going towards the execution of customers' requirements. And we maintain a single solution which is being developed in detail. We do the construction, then we deliver to the customer, and then we go to the phase of service.
How do we do this? Well, with this faces or macro facilities that appear on screen. One first, I plus D, which is where we develop concepts and technologies that will later incorporated into the ship. Conceptual design, functional design, constructive design. In that design, we incorporate all the planning of details, all the work orders. And then from there, we start with the construction of the ship, with the production and the testing and the sea trials. And for sea trials, we need to feed the process with materials, and in some cases with labor that the shipwright does not have. And so once we build a ship and it is approved, then we start with the sustenance or the support. I have marked in red with those phases which are important not because of the dimension of the work, but because of the decisions that are made. Then the cost of the product, about 60 to 80% in conceptual design and 80% in functional design, is defined in those stages that we choose or define the main equipment and the brands for that ship. And that is when you close practically the cost of the ship. A good engineering, a good design makes for the program to fall within the cost and the terms, so that bad engineering could just trash that. So you need to also plan well and get down to the lowest level of detail, because that ensures the production process. And while the execution does not carry most of the cost, then you have the construction and the purchasing of the material. Later, the support, depending on the unit, it could be worth almost twice the cost of the manufacturing of the ship. Now, this part of the process is important to mention when understanding where is appropriate to make the investments and what kind of investments, so that we may have an ROI, adequate ROI, for a good plan for digital transformation. Now, without being flashy or perhaps wanting to give your example, but without it wanting to be a reference, but how we at Navantia have understood the concept for our company, well, I will try and explain a bit what process we followed, what result, and what plans we have defined. The first and most important thing in digital transformation is that it should be done in a strategic part of the company. You cannot approach digital transformation as a single project for each area without any vision of uniformity. It has to be a strategic planning process, a process that defines what the purpose and the goals are, strategic ones that you have set out for yourself in Navantia. In that strategic planning process, we define these 4 dimensions or axes that we had to approach when executing our plan. And that execution plan we refer to as, well, it is the first dimension which deals with the income of the company, and also what the collections are, the accounts payable, and something else, operational efficiency and how to achieve it. And the third dimension is, and I'd say the most important in any company, which is the people. Those who build the ship, those who support or maintain the ship, the president, people, those of us who manage the company are people, and therefore we must place special attention on who will lead and who will work. And then there's a cross-cutting dimension, which is the one that ensures that every process, strategic process, is maintained in time, and that deals with culture. There's a mythical phrase within the strategist that the company's culture is you have breakfast every morning with strategy. The strategy is eaten as breakfast every morning. So that is why that cross-cutting dimension is so important. As you execute the plan, you must make sure that the culture accompanies that. Not only in terms of the execution, but the pace of the execution and the pace of the change. Now, that operational dimension where digital transformation relies has 5 key points. One, it deals more with production, do things more efficiently, and it deals with how, based on the data that we generate, that we companies generate, how we can define new business models and earn additional income. Second pillar is the maximization of operational efficiency and digital transformation. Always here, the theme is prioritize. It is very hard to encompass the whole in a company as large as Navantia. We have over 430 defined processes, and you cannot approach a transformation process by engulfing the whole in such a short period of time. That is why we need to prioritize what is key and then tackle those. Development and implementation. And here we talk about how Navantia has understood the adding of value to complex products as a frigate or a submarine, and how we can join these developments with the training required by our value chain. The 4 is the cooperation with our cooperating industry. That is, when one looks at the figures of how many people are involved in Avanti and how many people we have outside, and then you start sensing where to put the looking glass, and we need people to get on the wagon, to get on board and accept and embrace the systems. And the fifth is the driving of investments. And then all this needs to be done within the sustainability goals and the 2030 agenda. Part of our definitions to execute this plan, a strategic plan. One of the key levers is to ensure the alignment between what we do and the sustainable development goals. What objectives have we set out to turn Navantia into 5.0? One is development of the sustainable digital business model, leverage ourselves on technologies that will help us along that path to accelerate the change of processes and an improvement in operations of 20%, which is already seen as a pretty important challenge. Now let's go into the structural plan. We have divided into three main areas, which are: first is the disruption of the market, second, operational efficiency, and something that we've called enablers, without which we wouldn't be able to execute the plan. And they are, as I internally refer to them, as the road that allows us to travel towards our goals. Otherwise, we wouldn't be able. No, these axes we have divided into market, products, and services. Product very much focused on what's inside the ship and services, which is what comes after the delivery, the sustenance and support of the ship and how we improve on that. In operational efficiency, we have a more operational portion, which are the things that work within the shipworks, and that regarding the value chain and the operations of Navantia, and another portion focused on health and the corporate area, including finance, human resources, etc., how we can provide better services for the business, for the shipworks, and the manner in which we are able to balance the effort, operational wise, and being efficient and doing things with less, as well as the corporate side in terms of providing service with just the right resources. And then you have the digital infrastructure. Now, this would be more like akin to the drawings of a home, right? You build a home, you need drawings, blueprints, and you need to define plans. Floor plans. How are we gonna do that layout of the floor and what we put inside of each room? Now, in the digital realm, it's the same. Although you may not be able to see it and touch it, you work similarly. And therefore, we need to define a proper architecture and a proper platform or tools, which are the ones that will help us execute all that comes on top. That is, develop intelligent links, more efficient operational processes, and the other enabler deals with the people and the 5.0 culture and how we manage knowledge, how we need to be sensitive to the digital world, cybersecurity, and how that works with companies or affects companies. Each one of these lines then stems into initiatives, and we have to find. Right now, it's almost 100 different parts of digitalization, and they are in turn divided into several waves or temporary framework to order the execution of the digital transformation process. Now, which technologies we've chosen were those that you see on screen. There are two which we do not count as technology, but actually as technological lines that must be there. Yes, sir. Yes. Cybersecurity and the other digital platform. Anglo-Saxons call this the backbone of the information system of the company, which is what allows you to connect everyone. Not everyone can see everything. There are rights and privileges to view and use information, but let's just say that it allows end-to-end communication or connection of the entire value chain of the company, technology-wise, materials, materials from investigation, quantum materials, plastics, etc. Then we have additive fabrication, both the metals and plastic, RPA, which are used in recurring tasks, industrial robotics for our shipworks and manufacturing plants, drones with application in terms of industrial security or safety, all the way to inspection tasks, the cloud, to hasten the use of our processes, modeling and simulation. Right, we need to maybe detail a project that we are maybe working on would be simulation intensive, modeling intensive, then RA and RV, right, with applications in construction and engineering, and then IoT or Internet of Things, basically to speed up the connectivity of people and factories. Bear in mind that shipworks are large footprint, big footprint areas, and shipworks in Levante and Ferrol, we're talking about 1 million square meters, and well, those are pretty large plots. So anything that we can do to improve security, we'll do. Autonomous vehicles within the shipworks to move the logistics, materials, artificial intelligence. Well, this is a technology that I'd say brings news every month, and applications are developed every month. I think that just to mention one, it will be the technology that we will all use in 5 to 10 years, whereas now the applications are just starting to become mainstream, but this is going to become a mass thing. Now, blockchain. This is a technology that we are using in a tie-out. It is hard to find applications that will bring us a clear ROI dynamics and analytics. This is key when exploiting data, big data and analytics, and to exploit data during the construction process, and then 5G, which allows you to guarantee that connectivity. You know, the field of use within the shipworks. Well, we have 5.0 pilots within Spain and at the level of the shipworks, and then we have a project that we are presenting to the Ministry of Defense of Spain for use in naval applications in defense, for defense. Now, partners. Well, I've mentioned a few here, but we have a myriad part, which is fairly wide. One of the lessons learned here, and that I will present on later, is the selection of the partners. That is key to your success. Without the appropriate partners, it would be hard to embark on this journey. What is our challenge? Well, to transform ourselves digitally. We are a company with over 300 years of history. It is fairly large in terms of the number of workers as well as our external cooperators. And without any further ado, I will tell you about each of the lines of development in terms of digital transformation, what the content are, several of the projects. And this is the challenge that we in Levante have embarked on And every time I can, I try and share so that anyone who wants to join us or do the same as we've done, for good or bad. So I say the most important thing is people and culture. We have chosen some examples of big projects that we are engaged in and leading from within our human resources area. First is to create a change management team and a plan, change management for any transformational change within the company, whether by its own choice or because of a strategic alignment purpose, requires a team that is specialized on this topic. Change management is key to the success of a plan. We need to go over the leadership model and how a company should be led, right? Where we need to change our minds and make it more digital. We need to find, attract talent within our strategic plan, that line, the division, the people division. One of the challenges was to rejuvenate our staff, which has meant in having to let go a lot of people, but also hiring and attracting people. But for that, we need our brand to be attractive. So we need to invest in time and resources to be able to convey that message. Our diversity and inclusion plan, right? We need to avail ourselves as most as we can, right? For those people who've participated and cooperated, right? Because we need to capitalize on that knowledge, and then we have a project for officers to be more interactive for the younger generations.
Cultural transformation in the workshop, we have to go from top to bottom. It's not just a matter for the CEO of the company to talk about transformation. The message has to hit home. It has to strike home in terms of a cultural transformation program within the workshop, which is being widely embraced. These are some of the new spaces and also a commitment. We're going to start this year in October. There is a proposal so that the employees can transparently tell us about what's working, what's not working, and what improvement opportunities we can develop at the company so that in the planning of projects going on to 2022, we can fine tune the process. The digital architecture platform, this is another key part of the change management. We have to set up a highway towards the areas that want to digitally transform themselves can actually do so. We have defined a digital platform that links the transformation of engineering and our way of design to the management of operations and what is known, technologically speaking, as the ARP within the field of planning, that is procurement management, finances, and so forth. And there is an outstanding role of cybersecurity and the challenges posed by using new tools, connecting ourselves, talking to the cloud, and so forth. And the weakest link is not technology, it's actually the servers and the kind of security on the servers, not to mention people who may click on an email and that may lead to a huge data security problem within our organization. Okay, here we have some examples that I've mentioned. The ERP that we started a couple of months back, and there is the 4.0 digital platform whose focus is to develop an Avantia, a platform that allows us to develop products in a more efficient manner and also generate digital innovation. Later on, I'm gonna be expanding on the first point, but that is a key part of Navantia's transformation in terms of generating smarter products. There is a cybersecurity program which is also very strong within the company. The idea is to raise awareness and also develop all of the means to stop hackers, and so that we can fend those off within the company on the basis of cybersecurity. So, what exactly do we seek by means of this digital platform? Okay, we want to develop digital innovation and continuity. Digital continuity has to do with some of the issues generated by the various tools and platforms being used by companies in the market. Different databases and processes are developed, and a company cannot define perfect processes, and it is a challenge. And at the end of the day, we all make mistakes on our way to perfection, which is utopic. But what normally happens is that what a person in what a person is doing in engineering, another person is actually arranging data, and when there are different databases, this kind of problem actually grows a whole lot larger. So how do we correct a problem? By defining an architecture and a platform that allows for us to address any digital contingencies. When there are relevant data, the platform should lead the user to the environment where the data is being produced, thus leading to the continuity. And that is the challenge in terms of design, which at the end of the day, the idea is to set up the platform, which may take 2 or 3 years. Okay, I didn't touch upon this, but the implementation of this tool, we're already using the platform on the frigate that we're currently developing for the Spanish Navy. And we can already see different process areas that can be improved, which will require an investment in terms of the platform. Okay, for those who are curious about the solution that we've developed upon comparing to alternatives, we chose the Siemens solution. It is a solution that has different alternatives, which has been set into a platform, and the other product is an intelligent product. Where have we focused our development? One, we want to change the way in which we develop the product, highly focused on models, which are basically representations within a modeling tool that enables us to represent the characteristics of the system or the set of systems, leading to a model to determine the speed of the vessel or to represent the operation of the AC and so forth. Traditionally speaking, in engineering, there may be models, or going from the simple items such as spreadsheet, where engineers have their formulas and studies within a series of parameters determining the diameter of a pipe to the power of an engine and so forth. At this particular point, there are various companies that offer very powerful modeling tools which are available to our engineers. The generation of these models on a platform allows for the optimization of the process in such a way that I am able to know if my ship is actually going to generate the features that I need before I build it. And it allows me to see different characteristics or disciplines which were actually segregated before. The mechanic can develop his system, and the technician looking at the AC can determine if the airflow is appropriate on the basis of a 3D model. Now, this is one line. Now, the other key line is aligning the design to the cost. There are different ways to meet customers' design, and not all of them cost the same. The idea is to make the solution as cost efficient as possible for the customer so that the price is as competitive as possible through the use of new tools. The design is ever more collaborative, both within engineering as well as external sources of engineering. Digital twin design, what that tries to achieve is to use the models from the design phase to other implementations leading to vessel sustenance. One design is based on the predictive forecast, maintenance forecast through the use of AI algorithms. What it basically does is to export data. Of course, that requires a huge amount of data. When data are not available, maybe for the type of engine or the type of pump, when data are scarce, what you have to do is guide yourself towards accelerating the AI algorithm process, and that can only be done through the use of models. And the digital twin model is essential there. That has to do with the operation of the vessel on the basis of defense implementation, which is very sensitive to share, but it also has applications in terms of the vessel operation. Okay, another concept that we're also pushing forward in the execution of this strategic plan is modularity. One of the challenges in defense shipbuilding is the design timeframes. That's one of the lines which are most essential, and that can be done through modularization so that we can have a Lego-like system that can be consolidated. And when we bring that together, we can actually set up different models. Now, with design tools and the database libraries, we can get these types of concepts that formerly require too much information or too many people to be materialized. Okay, this section is the development of a plan in terms of digital twins with export capacities, um, combat systems that are ever stronger, and the configuration of different plans on the basis of temporary models. I will not dwell on this because of time constraints. The service sector has got to do with the development of smart designs and how we can enhance the customer's experience on board of the vessel, as well as for the maintenance of the vessel. This is the focus that we have given to this, and Avantia is devoted to the cost effectiveness of the life cycle. What are we trying to achieve? We want for our platform to allow us to approach the maintenance needs of customers. Clients tend to have their own ship maintenance platforms, and what we have to guarantee here is for the solution or for the tool used by the shipyards to interoperate with the customer in such a way that data can be exchanged safely and also add value to the processes developed by the customer. Along with the products, there are various time frames and stages. And the digital twin can also be added to the maintenance model. And it all depends on the kind of model. It's not the same to develop a model for looking at the operation of a given system than to develop a product to see why a given system may fail. The level of complexity and detail of the models depend on the questions that will be asked by the person in charge of maintenance throughout the life cycle. Okay, here we have a whole lot of work done and still to be done so that we can develop models and type of sustenance that can be utilized by our customers. What we are clear on is the added value produced by the digital twin to the customer is going to be enormous. As for the operation, what we focus on is for the shipyard to become a super efficient factory that produces vessels. This has to do with the physical means of the shipyard as such and how we conceive the construction of the vessel, all the way down to the means that operators have to be provided with at the shipyard so that the work becomes ever simpler and so that they can get information more easily, leading to a wider span of agility. Okay, what is our objective? First off, we want to simulate processes by capitalizing on simulation tools so that the planning of production is highly optimized. And then we want to achieve production automation. I would like to bring up an example of one of the developments that we are rolling out at Navantia, which totally illustrates this point. The supply chain and logistics are key factors when we manage hundreds of thousands of different materials on larger vessels. As for spare parts, it is important to integrate the information and the management of thousands of people who are not at the shipyard but outside of it. This is the plan with the objective of setting up shipyards and factories that become more efficient and better connected. I would highlight the uh, Pearl Block Factory, which we started out before summer. This is the design of the factory and it changes the traditional setup of construction. There is a modular construction model, which at Navantia we've been pushing forward since the 90s, and that's helped us to reach success for over 2 decades. This particular point, I would say that the reference in terms of construction and efficiency is actually closer to the figures of a car maker rather than a shipbuilder. And we've been using a set of methodologies that actually work for car makers and that can be exported to shipbuilding. And those basically have to do with setting up a block construction scheme. Once the blocks are ready, they can be assembled at the dry dock and then the ship can be launched or the ship can be set afloat by companies such as COLOMBIAMAR. The idea is to set up blocks that enable this kind of construction speed. As for the savings that this block system can provide us with, these are some of the figures. And then there is the corporate processes. Here we implement ERP and AI capacities, among others, so that we can optimize production support systems. Here, there is a plan, just like all of the other processes, And we have been working on travel and expense management, as well as integrating corporate management, supply chain, and digital culture along with the solutions from our ERP provider. Okay, as for lessons learned, if I can use my very last 10 minutes, the first message is that digitalization, we do have to get to a scheme of critical thinking to determine if this is the best process for the final objective, which is to deliver vessels to and efficiently maintain vessels. In doing that, there is a series of guidelines along the lines that I've provided to you by means of presentation.
No, we don't. It is not digital, but we have to do it. And to do so, we need to incorporate, ingrain a digital culture. Some culture that has to be more flat, more close to reality, and we need to attract digital talent. Today, we talk about native digital natives, because of course, the current generations that are not totally professional or are about to complete their university studies are closer to technology and technology means and tools than generation, not so much as mine, but intermediary among the younger crowd, but that perhaps are closer to retirement. But we need to attract the digital talent, and we need to find, and you can see it to the right, net management. The seemingly doing, you need that digital change to just keep in the process. And improper change management will just throw away investment. How about the robot? Put a robot, get a robot, and one of those robots that you see jumping and dancing. Well, the buying of the robot is not enough. If you don't tell people, if you don't attract people for the robot, that robot will just collect dust on a corner somewhere. So you need to make sure that each project, each transformation initiative is accompanied with appropriate change management. Because when we don't, the goals are not met. Project goals are not met. And the other important part is that we need to do an ROI, a return on investment, and we need to have scenarios. Some scenarios that are not as favorable as one thinks. If you come into this believing that this is an easy thing and that you will achieve it by doing one or two, then you are far from understanding the challenge. We need to have optimistic scenarios, the worst case scenario, and work on those figures. This is key. Second, I'd say, not all who come to talk to us about digital transformation and digitalization, companies that do this, not everything is applicable to your company. And not all provide you with the ROI they promise. So we need to ensure a rule that is used a lot in IT. Think big, but do small things to test what works and what does not, and then go fast. If you make a mistake, do so, but fast, and then change, adapt, because the path is not a drive it to completion, and it has to go from top down. The first who needs to drive that vision has to be the board of directors or the president of the company. Another large risk, and in our case, Well, it remains to be seen, but for that, I usually include it in my presentations so as to serve as a reminder, because in the end, you need to get to your destination. If you want to travel, let's say from Bogota to New York, well, you have to get to New York. You know, you cannot find yourself in Washington and think that you've made it to New York. So there's a technique here, which is to start from the end and work backwards. And for that, there is something, it's like an initiative. You'd have to reprint the article where you see the success of the digital transformation in your company, and what would you put in there? The fact of writing something and seeing what you want to achieve helps you in a way to achieve those goals, because you will include the elements that you will need along the way to get to your goal. There is one of those funny things, digital transformation teams successfully find the wrong thing, because if you're not careful, you'll end up buying what you did not want. Now, another key lesson learned, and you see it when things don't come out well, when you don't gain experience by doing things well, but by doing things badly. One of the things is to look for adequate partners. And I've insisted several times, the path is carved out. You have to be clear as to where you are spending, and then correct your path to make sure that you are not deviating. And for that, it is very hard to find a partner that knows everything. So the important thing is a good partner who, together with you, will be able to make the right decisions to follow the path. And then after our search, at least I am convinced that we have the appropriate partners for the challenges that lay ahead of us. Something else, which is always fairly complex in digital transformation, is to adequately size the effort from the standpoint of the cost of the project and going through the time. So you have to assume that you cannot do the whole thing. So you need to prioritize, as I said in my opening remarks. It has its own keys, right? But within the key process, you need to prioritize what to do first, what to do second, and within that transformation process, what are those that will give us the most benefit, the most value in the company, and which will give us the least. There is an expression that I add there, because to digital transformation involved managing an existing business. Doing digital transformation is like changing the turbine midway through our flight, right? So imagine you'd be in a plane, and then you look out the window and you see people changing the turbine midway through the flight. So when we are setting up a new digital platform and then designing, and at the same time we'd be designing the frigate, well, that poses a challenge. But it is done because the value that it will add to the company is fairly big. So it is key to review and then discard other projects that may be smaller or may not give you that ROI that you were expecting. Which brings us to expectations. Manage expectations. When we are aware or are conscious of what the expectations will be, then you can, when you don't know, you may get it wrong. So you need to make sure that you have the right way to establish those temporary goals and processes. And just like you see in the quote, be mindful when setting expectations with your boss. Once set, deliver on them. Otherwise, somebody else will come in your stead and will generate much more adequate expectations. So be mindful of the complexity of digital transformation and the challenges involved when establishing that plan, and when establishing those milestones. But once you set them, make sure you deliver on them. And without any further ado, I am ending my presentation right on the spot.
Oh,
Dear Dr. Donato Martinez, thank you for your extraordinary presentations. We have received many messages from many countries recognizing the value of your contribution. Allows but a few questions before we end our participation. What can you tell us with respect to new autonomous and hydrophone-driven frigates within the growing shipbuilding industry in Spain? Well, let's take it by part. Now, the autonomy of ships. We have a smaller ship, I'd say, a speedboat with autonomous capability and remote capability, which is not the same, you know. This is either autonomous or remote based on the needs of the user. And that, I'd say, is a technology that is accessible, it's available, and it depends more on the requirements of the client more so than technology or the need for technology. So not only in Spain, but elsewhere in the world, there are companies that provide you with these types of technologies. Now, hydrogen propulsion, the challenge in shipbuilding and the size of the ship we do has to do with the level of autonomy, right? The distance the ship have to travel to get to their destination. Now, hydrogen is a molecule with a lot of energy. Yes, but basically we use it differently from how, say, nuclear fusion would use, which we still don't know how to do. Like, but as a fuel, you need a lot of hydrogen, so much that would allow you to use it right now. Now, the technology we have in submarines, right, in the Spanish Navy, will do generate hydrogen, but from the breakup of another molecule. There are some applications based on ammonia and H3. We basically have a not an identical process, but a similar process. Right, there are other applications. Now, hydrogen we see as a clear application, but for short distances. And we have a project submitted along those lines for clients with say, the need to use ship for short hauls. Thank you, Dr. Donato. The next question is, how have you articulated these digital transformation processes with the sustainable development goals and the 2030 agenda? Well, the first thing that you need to ensure is the interest, the raising of awareness of the people and companies of aligning with those goals. So we have set out a goal for ourselves, which is important, right? Which is our carbon footprint. There is one thing easier to do at the local level, the shipbuilding level, at the shipworks, and it deals with the fabrication processes, making them more efficient, use green energy when consuming energy within the shipworks. There is a harder challenge, which is to stop using steel, for instance. It is a fairly important challenge in terms of the defense ship. We're still far, but we are working with companies such as Arcelor and others in hopes of reducing our footprint. But in any case, any project submitted within digital transformation and which we approve within the board of directors, well, part of that presentation includes an indicator of objectives to which it is aligned. And we are now in the midst of a project which we are going to deliver on late this year. Very serious tool that will allow you to achieve those carbon footprint goals, and then to measure them by measuring them, right, through a project. So that when we approve a project, we make sure that that will be reflected in the reality as indicated by KPI. Well, perfect, Dr. Donato. Thank you very much. And with these questions, we will now proceed and make some conclusions on your presentation. Your history is long, over 25 years. Well, clearly, your option was to choose technology and the development of technological options that will generate growth for computing. It's interesting when you say that digitize is not equivalent to digital transformation. We need to redefine the entire process, question everything if necessary. Also important when you say that it is not about appearing, so but being. And technology, yeah, it is right. It is closer to the newer technologies. Now, thinking about the ROI, but an ROI based on knowledge, products, and services that are intelligent, highlighting your contribution to this macro project, the construction of the digital twin for the new F-110 frigates in the Spanish Navy, no doubt intelligent products, but which involve a lot of the key technologies of the 4.0 technology. You leave it also with great learnings of vis-a-vis the selection of strategic alliances, both locally and international, change management, cultural management within an organization, which implies the attraction of new talents. When thinking about digital transformation, where the message needs to be ingrained in the mind of not only the senior management, but in every mind of everyone who was part of the institution. It was interesting to see that those 14 key technologies, right? This transversal dimension where the digital platform and cybersecurity are two sectors which are totally key. Now, for Colombia, a country that is looking to the future with a clear intent of development of the shipworks industry. All these defense products that you talked to us about, the combat management, the integrated platform system, all linked with renewable energies, the life cycle, no doubt, open pretty important paths for the development of new technological capabilities that will support the operational capabilities of a force as the Colombian Navy is. Dr. Jornada, thank you very much for your keynote presentation. So through the platform, we have received many messages acknowledging this important contribution to our 7th International Naval Design and Engineering Congress. Well, thank you. It's been a pleasure to have been here with you this morning. Thank you.
Caminando por el cuadrilátero, round 3. Cerraste el micrófono. Ok.
Agradecemos a nuestro chairman y
Okay, we would like to thank our chairman and our guest, Dr. Martinez. We're going to continue with the program and we'll continue with the forum on the challenge of new technologies applied to digital transformation and the navigation industry 4.0. We now give the floor to Rear Admiral Jose Joaquin Amezquita Garcia, moderator of the forum. Rear Admiral Amezquita is a professional in naval engineering with a focus on electronics. He has a specialization diploma in radio communications from Universidad del Cauca. He has undergone graduate courses in defense and human resources as well as a management program at Universidad Javeriana. He has a master's in national security and a certified professional in project management as well as a Navy attaché in Washington back in 2013 and 2014. He was the head of naval planning and also a force support official, and he now performs as the National Maritime Director. Mr. Rear Admiral, thank you. Okay, I hope you can hear me now, but I would like to reiterate my greetings to all of you who are live, as well as those of you who have connected online. Okay, before I introduce the high quality panel, sorry, that we have in this meeting, I would like to tell you that in previous versions of this event, I had the opportunity of sharing, but also debate with Rear Admiral Tascon that he's in the heart of Civil. He has participated in every single event that we've organized, and I would like to give him my best wishes for a speedy recovery and so that he can join us once more. Okay, looking at the previous presentation, many reflections come to mind, and on a daily basis, we get a lot of information about digitalization, digital transformation, and the challenges of the moment, and that's the topic at hand. And I would like to introduce our panel members now. First off, Dr. Paola Mar. Paola, welcome. Thank you. I'm very happy to be here, and I would like to join Admiral Tascon's feelings. He planted the seed for this event, which generates a space of academic exchange around something as important as naval engineering and innovation. Okay, Dr. Mar is a business manager with a PhD in industrial engineering. She's an entrepreneur, a researcher, a writer. She has authored different scientific papers with a focus on the academic and public sectors, as well as corporate issues and innovation. Right now, she is the Vice Chancellor of Research, Outreach, and Innovation at Universidad Simón Bolívar and CEO of Macondo Lab. And I love the name of, um, of that enterprise that supports entrepreneurs who take risks in the accomplishment of his objectives. Now I introduce Miguel, who's a specialist in power and control from Universidad Técnica Cataluña and a master's in electronic engineering instrumentation from Universidad de Barcelona. Miguel is a naval engineer from the Almirante Padilla School of Cadets. He has taken different positions at the Navy, and I would like to highlight the direction of the Naval Center, and right now he's leading the Science, Technology, and Innovation Office at the Naval Directorate. Miguel, welcome. Rear Admiral, thank you. Good morning, Paola. I would like to join in the words of Rear Admiral Amezquita. I would like to greet Admiral Tascon and wish him a speedy recovery and a warm greeting to his family. Welcome for the invitation to this important forum. On behalf of Admiral Gallo, who's the head of formation and training at the Navy, a position on which my performance depends. Okay, Miguel, I would like to introduce Maria del Pilar Noriega. Maria del Pilar, good morning from Bogota. Okay, Admiral, good morning. Thank you for the invitation. And I would also like to thank Admiral Carreño, with whom I've been able to share different issues around the topic of technology. Maria Pilar is an engineer, is a chemical engineer with a specialization in polymer chemistry and extrusion technologies. She has a PhD in mechanical engineering with a focus on the processing of polymers from the University of Madison, Wisconsin in the US, and she's worked in different research centers as well as university research education. She has done work in energy audits, processing of polymers, polymers in pharmaceutical and nutraceutical applications, transfer and licensing of technologies. Currently, she's performing as the coordinator of the convergent technology focus at Misión de Sabios in Colombia. I'm going to introduce Jose Miguel Hinojes from Spain. Jose Luis is the Marketing 4.0 and Intelligence Director at Navantia. Okay, good morning, Admiral. Thank you so much for your introduction, and I would like to join in the best wishes sent to Oscar Tascon and his family. And I'm very pleased to see you again and to be able to talk to you again, although it hasn't been able, I wasn't able to go to Cartagena de India, so of course that would have been a better situation. José Luis is an oceanic and naval engineer from Universidad Politécnica de Madrid. He's responsible for international commercial actions for military ships. He's headed engineering projects at Navantia and previously in the production department of that shipyard. He's also performed as the commercial head for military vessels and currently he is the director for Marketing 4.0. Okay, in order to make this form even more exciting, I would like to propose a couple of reflections from Yuval Harari. In 21 Lessons for the 21st Century, he asks, how can we prepare for the upcoming world? How can we prepare for a world filled with uncertainties and above all, filled with innovations and what that implies for us and for our children, what the future brings? And of course, most of the focus of the book revolves around technology and biotechnology. What does that mean? Okay, I was looking at some notes and I found one of the statements from Admiral Tabridis from the US Navy, who reminded us about 7 years ago that a destroyer from the 60s of the US Navy had lower processing capacity than one of today's cell phones. This indicates the rate of change that technology has been subjected to, how the past 40 to 50 years, the change curve has accelerated, but we still have a long way to go. And part of that exercise has to do with new technologies. Most probably back in 1965, Gordon Moore formulated his law forecasting the number of transistors that could be put into an integrated system. He wouldn't imagine that today we would be talking about technologies that actually make his premise obsolete. But we also need to ask ourselves, and Jose Luis, this is something that I took from one of your publications, and it is that back in London, to be exact, at Portsmouth, there is a topic regarding vessels of the future. I had the opportunity of attending this version that has to do with submarine fleet in the years to come. And we don't know if we're talking about future vessels or futuristic vessels. And all these technologies that we have been incorporating, all of this growth, we can see that the leaps, the technology leaps, don't happen so fast. And we're still thinking we're still wired in a traditional manner. Now, we talk about technologies that cut all across this exercise, and we can talk about the LTE technology, which is what Bitcoin is based on. If that industry influences over shipyards, could Cotegmar, for instance, get payments in Bitcoin? And I remind you that the President of Salvador incorporated as a national currency Bitcoin. Just a few days ago, we talked about AI, extended reality, and we talk about quantum computation, and that is going to have an effect on what we do in the shipyard industry. The question is how much, when, and how. And in that exercise, we need to ask a question. Are we actually prepared for that? At our universities, Paola, are we developing the appropriate models to produce the professionals that we need? Countries such as Colombia, does a country such as Colombia have the capacity for absorption. And at Cotemar, do we have the human talent? And not just that, do we have the resources for developing those technologies and for taking that leap that Dr. Martinez was talking about in the previous presentation? How can we fund that? So I would like to close this introduction by paraphrasing Harari. Okay, how to prepare our companies, our universities, and our shipyards for this that we call the digital transformation. Okay, with this question and with this prelude, I would like to go to the first question. This is a question for all panel members. Okay, what do we talk about when we refer to the 4.0 industry? And if you allow me, I will begin with Maria del Pilar.
Bueno, antes, buenos días a todos y a mis colegas
Okay,
panelistas.
good morning, everyone, dear panel members.
Bueno, con la industria 4.0
Okay,
estamos
Industry
hablando de la digitalización,
4.0 talks about digitalization.
todo este tema de la automatización,
We're talking about automation,
convergencia de tecnologías,
use of
tecnologías
robots,
de
convergence of
peso,
technologies,
ciencias básicas,
significant technologies around basic sciences such as nanotechnology
y una parte
and information technologies. And there is a clear component that is neuroscience.
como centro
Human beings are important as the cornerstone of this transformation.
compañías inmediatamente, otros de manera
At different universities and human groups can go about this immediately, others will do it gradually, but the idea is to have all of this information in real time, being able to process it in making decisions and creating value on the basis of that with different possibilities these days, such as the Internet of Things, blockchain, augmented reality, machine learning, and so forth. But the core component is humankind, and that ought to have a huge impact on society. Now, let's pass the question on to Paola. Okay, how does academia look at Industry 4.0? Okay, as all sectors, we see that from the perspective of huge challenges, and we need to develop and speed up our processes. We cannot say that we've reached some breakthroughs and we've developed the skills, but in the face of COVID-19 and the pandemic, all of this accelerated. We were going down the path, though slowly, without understanding that society at large actually changed. And COVID accelerated that. And in Colombia, we've been in a process of assimilating that and assimilating the challenges. And for the Industry 4.0, just like the previous speaker was saying, we need to rethink education from a digital perspective. The digital does not imply simply working online. It's also how I provide technological skills and how I rethink the way in which we strategically arrange for higher education in Colombia. So we need to speed things up. I'm going to be dealing with some topics related to regulations, which is complex. But COVID-19 has already pushed us into this scenario. It's not just digitalization. There is a model that is called 6D. It goes from a disruptive model of digitalizing but also democratizing the processes. And one of the biggest exercises of this innovation is how we can make this Industry 4.0 more democratic by means of training, the skills management, as well as technologies. Okay, and I'm going to jump the gun a little bit here, but I would say that in Colombia, this is actually possible. Okay, Miguel, what is your take from the perspective of the Navy regarding the Industry 4.0? Okay, there is data. The data is the new raw material for business. When we talk about business, we cannot exclude any type of company. As a matter of fact, as an institution, from advanced platforms such as our um, surface vessels, without mentioning the air platforms and the submarine platforms. We need to look at these new capacities being offered by all systems and subsystems, which are highly sensorial. There is a great deal of data that's providing us with tools so that we can achieve processed information on the basis of which we can make vital decisions at an organization such as the Navy in real time. So from the start, I mentioned that the Industry 4.0 for the Navy, for Cotecmar, for all of the maritime companies is basically a highway of opportunities. In addition to that, Mr. Admiral, if we look at the technological challenge that we have in the face of our 2042 innovation program, which is a huge technology wager, not only for the Navy, but also for the whole nation, because we're going to be able to develop technological skills on an industry and technological basis in defense, which can be transferred to any other sector. Okay, Miguel, thank you. And now I pass the question on to Jose Luis in Madrid. Okay, Jose Luis, from Navantia, what is your perspective on the Industry 4.0? This is specific for the shipyard industry. Okay, the way we look at this, it actually summarizes some of the points addressed by my panel peers. It incorporates many different technologies that open up the doors to a different way of doing things and for us to offer different products and services, which, as Donato was mentioning in his presentation, is totally going to change our business model. And if I had to summarize everything that these changes are going to bring about into a single idea, it's just like Maria del Pilar was saying at the beginning. The key factor is that this is only going to make sense and this will only be useful if we keep people at the center and at the focus of this whole thing. The innovation will prevail as long as vessels can complete their missions in a more comfortable, efficient, and efficacious manner. The new ways of building can only be useful if workers can produce under better conditions and at higher levels of quality in shorter time frames and at lower costs. And the management models that now we use can only be useful if they help us, all the data and all of the information lead to benefits for the people using the data and generating the data. If not, we're going to be wasting time and money uh, because we're going to be implementing processes that are not useful and that cannot be utilized in the future. Okay, and on the basis of these concepts, I move on to the next question. Okay, then what are the most significant changes in the way that we manage these new companies, digital companies? But in addition to that, what are the challenges that we would face in this new way of management? And I would like to ask Maria del Pilar to open up this discussion. Okay, as for management, it is important for us to focus on value generation. We need to have the infrastructure in place, satellite infrastructure, broadband, communications, digital platforms. In your case, you should have platforms similar to those of conventional maritime companies such as navies and all of these various types of platforms. That's basic infrastructure to the service of this new management model that ought to generate value, innovation on the basis of good science. In the case of Cotecmar, of course, we do have those possibilities. And the idea is also to generate services, not only on an external basis,
sino al interior,
for the Navy as well as on the inside, so that we can get benefits for the private sector, the public sectors, consumers, and society at large. So if we don't manage for the Industry 4.0 to go beyond the infrastructure, the basic infrastructure, and generate true value and leading to innovations having an impact on markets and society, then there is no sense to this. And I would say that the champion there is the management leader that can actually guide this process in the best way possible with their um, human talent. So, Maria Pilar, how do you see this whole issue from Navantia, from the Spanish shipyard industry? Obviously, all of this new technology shifts the way in which we look at things, and the way of looking at things includes managing shipyards, such as in our case, and that implies rethinking everything. Donato gave us as an example the appeal to new talents or internal processes such as travel management, expenditure management, and so forth. And that leads us to think that technology opens doors, and we can apply that in a multiplicity of places and aspects implied in shipyard management. That's why it is so important to think, to stop and think what kind of steps we have to take and what exactly we're going to prioritize. What is the first thing that we will do? What's the most relevant thing for us to do? And where we're going later.
It is very easy in this 4.0 world in any company, but more so in shipworks such as our case or COLOMBIAMAR, where you generate such a number of different tasks and you have such a big number of relationships with industry partners, customers, inspectors, external entities. It is so easy to get lost in that attempt to apply technology that leads you nowhere. And like Donato said, that do not generate a visible ROI and not in the not too distant future. I think that what the most important is to be able to stop and think and then determine where we will invest and what ROI we expect those investments to provide us with. And when we validate that we are on the right path and take the additional step forward, if we determine that the road is not leading us to where we want to go, then stop, think, and change course. Now, possibilities that are open to us with the new 4.0 technology are so big that we need to specify, we need to prioritize, and we cannot do it alone. We need to go out and get partners. We need to add our environment, our surroundings, and not turn into a digital island that is unable to connect with what surrounds us. In a world where no one will interact with us, we must not lose sight that our supply chain, our cooperating academia, universities, centers of training, we must all share efforts, successes, and focus on one same direction. Thank you, Jose Luis. So I pose the question to the people present here with me. Paola, what is your opinion on the new management in the digital era? Well, let me comment about some theoretical elements and then a personal so when COVID started, we were locked up in our homes and we thought it was going to be 2 weeks. When we realized that this was going to be longer, I called my director and I told him, look,
Tema de tecnología. Este es un tema de
this
estrategia.
is a problem of corporate strategy, of operational models, of changes in the business model, of changing the qualifications of the work team. This is not just installing a platform to continue working. No, this is more about digital transformation, but living it as a manager. Today, we can export services to Chile, Panama, Spain. What we did, we'd never thought that for us. So what's important is for us to understand, one, that this is a business strategy, that our customers are always connected, that the speed of change is blinding, that the new business models and operation models are new, and that there are facilitating technologies that we need to understand. I need not be an electronic engineer to know whether robotics is going to be placed, or be an IT engineer to know what the artificial intelligence robot works. My work is to think about the strategy to incorporate those things. So it's about people. So innovation is not an intellectual process, it's a social cultural process. The challenge is not creating technology, but how we adopt technology, how we change our competencies, how do we de-learn. And there lies the this beautiful technological revolution that we're witnessing. Thank you, that is very inspiring. Miguel, from the Navy, it is not a company in the conceptual term, but it does have important responsibilities. And so how about this new way of managing things? Well, Admiral, yes, it is viewed as a technological challenge, the change of the rules. Just like Paola said, we are not only talking about technology, we have gone through 3 previous industrial revolutions, each with its own challenges. And these challenges have generated new models. Today, we are witnessing a very complex revolution, a revolution that has not allowed us to leave that 3rd industrial revolution, when we are just starting to rethink processes under a new working scheme, where, as I told you, presently, sometimes the people are the main actor. As the Navy, we need to have a direct connection with all the units that depend on a control center. And that is where the possibilities that these enabling technologies provide us in this, that's where the role comes in. How to avail ourselves of what machines do, and then have the human being engaged in much more important processes, such as generating well-being, quality of life for people. It is part of this new scenario in the 4.0 industry. And stepping aside here and commenting on the previous comments, I think it's important to talk about the why of this development. This development has a reason. There is an impact that we seek when we develop I plus D in any of the environment, and that purpose is setting a path for us. Just like Dr. Donato Martinez said it some minutes ago, to be able to guarantee that digital transformation not only stays in what is technology, but that it is capable of reaching each and every person, because that is the main component in any 4.0 process. Understand that the human element gains a much more important role than in any previous revolutions. So I have to acknowledge that of this anthropocentric perspective in these presentations. I love it when I hear that the human being is the center of all. And I think we must not lose sight of that. So I believe that we've built this conceptual base, which now will allow us to engage in particular matters with each of our guests. I'll start with Jose Luis and Magic. Jose Luis, In Navantia, what has been the biggest challenge that you've faced? The next step in your journey toward 4.0 shipworks, what have you found there? What recommendations do you have for not only the Colombian industry, but whoever is part of that which you've already mentioned, which is an ecosystem in this transformation process? Well, no doubt, of all the challenges and opportunities generated by this situation, perhaps the most important challenge is, again, people. First, because we need to put them at the center of things. Second, because we need to understand where the people were the moment the digital transformation started in Navantia. Then think on ways to make the people change their habits and their way of doing things so that they may evolve. And for us, it has been an important opportunity to incorporate younger people, younger generations, because of the circumstances of our companies. There were a moment during our history where we were not able to incorporate new generations, and that has helped us in this process to change, which, by the way, has posed a new generational challenge, which is to make different generations understand each other, which is not always easy. And aside from that, but never losing sight that we need to keep people at the center. And just like Donato said previously, our human resources division has played a fundamental role. It has developed important change management processes, the adoption of new technologies, cultural shifts. From there on out, the next opportunity, big opportunity and challenges to change, but to change without holding on to nothing. Being one of the oldest shipworks in the world, in our case, a company with over 300 years of history, I always jokingly say that to make a cruise ship turn is hard. Inertia, history, and the way of doing things that we've always done have a weight, and that is not changed from night to day or it's changed easily. But the speed at which new technology is arriving forces you to attempt as fast as possible. Otherwise, you will lose one place and you'll never get to the next, and your digital gap will just keep you farther and farther away. So the big challenge is to find, adapt ourselves at the appropriate speed, pace, but without losing that heritage and that history, without disconnecting ourselves from what the shipworks industry has always been. It is a challenge, but at the same time, and like Paola said, it's very, very exciting. Very, it supposes for all of us a daily enjoyment. It's a joy to try and contribute one more grain of sand towards that change. And well, seeing it, 2 years have gone by already in Navantia. It is impressive to see the company that we have today as compared to what we had 2 years ago, right? And we are being able to adapt to the new times. Thank you, Jose Luis. And in that sense, then what are the competencies that our workers need with a view to the future? Not only the people in the yards, in the field, in the elevators, but also management. And these competencies, what would be the make, for instance, of hard skills and soft skills? What's your take in Navantia, all that? But for me, this is something that I like especially. Being a naval engineer and having started my career in production, then engineering, then commercial, and now currently as marketing director, the skills that I have had and capabilities that I have had developed have varied a lot. I think that today in any industry that is done in 4.0 industry, it is obvious that you need to work with technology, and therefore you need to be able to understand how that technology works and then work it. You don't need to be an expert programmer, but you do need to know what is happening to get things. But at the same time, this technology you have to use, explain, share, sell. You always have to use it with people. Therefore, the skills, the communicational and social skills are fundamental. For me, it is a mix between the technical and the social skills. That is where every activity will develop. And being in engineering and to complete where I am and then where I am now in the marketing world within the commercial division, it is a moment that I am enjoying fully. Because with this technical background, to have to develop all those soft communicational skills, well, I find myself pretty much at leisure or at ease, and I think that's the way that we should take, and that's what our employees should do. You know, in the case of the Navy, in the case of the Navy student, in the case of the university, that mix between the technical and the social skills, that is where all the activity will evolve in the upcoming years. So yeah, we'd have to ask Paola, what is then the role of academia in this process? How does how can academy contribute towards the appropriation of these technologies in 4.0 and in that digital transformation process within organizations? Well, one of the big challenges that we have commented on, all of us today, is, and definitely, we have a problem with that microphone, and it is important in order to understand how we must go about it. There is a beginning, I believe that the fundamental goal of this. Si me están escuchando en máster, esto tiene un problema. Ese micrófono, cámbienselo, por favor. El micrófono hay que cambiárselo a esta señorita. So I believe, tiene que cambiar el micrófono a esta señorita, porque está quedando sin pila, man. We need to reorganize university of those that we are working to and who are not native of the 4.0 industry. And again, I'm losing her. See? In this intersection between the social and technological. Thus, the technical skill and there is a model, and it's, I would like to think about there are domains. So, Camalo, please do. Thank you. And University Simon Bolívar, we started with a bold proposal, and that is the name of our center, bold, because we have to be bold on how we will work in those two lines, understanding the competencies, the technological leadership, the technological domains, and the social skills. We have this very different interdisciplinary center, different from what you are used to seeing in universities, will ultimately do not generate the skills that my panel peers have mentioned, which is a way of envisioning, not when offering careers, but the careers, you know, in responsibility. As a society, we also have a responsibility. What sort of society we will mold vis-a-vis this 4.0 industry? What do we want out of all this technological revolution as a society? And I believe that universities are also there to open those spaces for discussion, for dialogue, but also for reflection on to what point do we want to mold this? And that is why we created this Bold Center. So we have already implemented AI with student professors company. As I said, we have had to work a lot with the health sector in Barranquilla, and the physicians tell us, "Oh, this will replace us." No, no, the technology will not replace it, but the one who does not know how to work with it will be replaced. But we have a challenge as a universities to be up to speed with the changes that are being implemented. Paola, I think it's interesting, the concept of the domains. Why not talk about that, Because I believe that it is a very interesting interpretation that which is taken to industry by academia. Let's not integrate careers as we have done in the usual manner but look for a new proposal where we may better respond to the needs of an industry, of a changing industry, but also one that is being challenged, particularly by society vis-a-vis new fields. Surely, in the industry a couple of decades ago, they wouldn't have asked too much about the environment or about corporate social responsibility, but today are paramount. So please elaborate on that. Yeah. In fact, it is one of the challenging topics, and I took it a lot from Singularity University. That is the center that I am reviewing in the doctorate, the PhD program, and in the converging industry, and in our production system in Colombia, in the Caribbean, do AI. We need to rethink ourselves. Why 4 years as a systems engineers, when it is best to concentrate on having a technological domain in these converging technologies and on these technological pillars of 4.8, which are real, are here, and which we can actually progress with. We would need to repropose, but we have huge regulation problems in Colombia because it does not allow us to innovate as an educational sector. Up to what degree standardization will prevent us from being up to speed or aligned with the current reality? Well, where I work, we are working on leadership and delivering new educational proposals. For instance, this Tapia Center, Macondo Lab, as we have used it as a laboratory to create the skills for students in that 4.0 industry, right? Because we have learned that even though you may be a lawyer, you can learn how to program. You can have a technological domain. You have to be a very good human being, transform leaders, and with that, people will fly. Our youngsters just fly, not because of the career, but because of the experience, the real hands-on experience. And industry takes an important leading role here. Let's not wait until the end of the project, but work with the student from the beginning, creating real problems. Work with them and not wait until the educational system produces them without the competencies. Right, so I believe that we have an interesting job accompanying. Now I'm going to give you another point. Sometimes we want to hire employees in companies, more so in the technological sector, where there's this huge boom and there's no people to work in systems, especially big data. And then these people jump from company to company, so I have to retain them. Well, one of the things that we are working on, instead of hiring an employee, let the student be the owner of a company, because you will never abandon a client or a job. All those things are disruptive, but I believe that those are the moments to experiment and turn this revolution around. Very interesting. I have to agree that technology and business models move much faster than the regulations do. And in that sense, those of us with regulating responsibility must be more assertive and read more quickly. To not encumber, to not delay that development that takes place in companies. And with this, I have to ask Maria del Pilar, How is Colombia doing in its preparation for that digital transformation? How good are we based on that great job done in the Wise Man mission, with the contribution of several areas of our daily life? How are we preparing ourselves for that challenge, Pilar? A pretty important question, Admiral. I see several things that have happened from 2019 to here. An important surge in the country in the number of additive manufacturing. That is one of the layers of value that we see as a critical success. Examples of companies such as Schusport, Bogota, Materialized in Medellin, and so many others, precisely in that layer of value with new technologies, doing customized manufacturing, which require no molding. And that is why it is referred to as additive. And they are generating innovation especially they are new services that the country did not have. The first focus of additive manufacturing started with the spare parts, right, for the car, the automobile sector. But nowadays, we have taken a leap forward. And we are seeing equipment for additive manufacturing being traded and or fabricated, which is important. In the case of materialized, it's very interesting because when a human has an accident, a person with a fracture, an occipital fracture, with the medical data, you would go in and replace it with the polymer. Obviously, all FDA approved, and people have that new life. I believe that for the Navy, for our armies, all this is very important. This opportunity of additive manufacturing, prostheses, and all that. That is a sector that evolved in 2 years, but geometrically, exponentially. Now, which other sector advises? Well, new materials. We are looking at that bio boom. The country is the second most biodiverse globally. So we have biomaterials with biomass, bioproducts in sectors such as food, pharmaceuticals, cosmetics. So new companies have come up. We all saw in the end of the year the number of new startups in our areas. It was like 350 young people in this new area of technological convergence. They're doing it, and they're doing pretty well. But also to emphasize here what Paola mentioned on the human resource. When you look at the infography, the first 3 lines are key. One is how we train the human talent, how do we retain it? Because when we look at figures of the transformation of the 5 or 6 years transformation is pretty big. We have nothing against the migration, but we have to make sure that we have a critical mass and high level within the country creating value. The other point is the transformation of the education, which begins from the primary school, then secondary, and the university. So transformation occurs from the bottom. We have an extremely long, time-consuming educational cycle. I believe that it can be shortened. And in fact, if we don't do, people in Europe are already doing it. We visited 60 different places in our country, and we were surprised to find groups of young people in Nariño, in the south, departments that are very different from what is normal elsewhere in the country. Just, rendering services in Asia and Europe. and how they were trained. Well, they were trained with the new world university. So they had the University. They had the IBM formation that is made to order work, made to order, which is not happening in Colombian information and university. And I also like to talk about ethics. Ethics is failing in the country. There's nothing new. And it's also operating in the world. We must say that. So let's talk about ethics in humans and let's worry about that, digital ethics. Impressive. Look at how data move through nations and permits or not the required, but but this takes us to this critical structure, and you see it in the second level, the digital layer and the digital ethics, the security of data is very important, not only for human beings, in terms of the digital ID of everyone, but also in the case of the Navy, each airplane has an ID and it must be unique, and that all from all of that we may get real-time information to enable adequate decision making. Thank you, Edgar. Interesting, this model of critical architecture to add it onto our models. Now, looking at that takes me to then reviewing one of the first columns, which is public policy. In this line, recognizing that the Ministry of Science and Technology is perhaps the youngest ministry of the executive structure. Well, one would need to ask, what strategies would Science be developing to favor that process, to familiarize people with the technology, with the generation of skills, of competencies? What can Maria del Pilar tell us about this? Okay. Well, a science ministry is about, I think that we need to talk about the interaction of all the ministries. A ministry of science by itself cannot achieve the effect and the impact that we need as a nation, depending on the type of the project. Let's talk about a topic which supposes great challenges in the country. Bioeconomy. For bioeconomy, together with technological convergence to have the impact that we require, well, it goes through the joint work with the different ministries, which is unfortunately not clear. So my bioeconomy means close relationship between the Ministry of Science, Agriculture, Industry and Tourism, Environment, TICS. So this interministerial aspect needs to be promoted in the country. It has not been the tradition. So to avoid or to prevent what we have seen, which is to leave everything in a single ministry and for it to be the single engine to drive this 4.0, it's something that we must change. We must avoid. There are leaps forward that we have made. We have a unified information platform for projects that are in Impulsa or in Conciencias or other incubators. We see them in one place, but we need to modernize the royalties. We need to make our mind more agile, but also for the sake of agility. Also, let's talk about controls. It is important that resources, that financial resources, human resources, information structures be also well used to avoid the problem. I see in the last invites, especially for tax relief, we see more and more sectors getting those tax reliefs. We see what happened in 2020. More or less 70% of the benefits happened in mid-sized companies, 30% in large companies, and we are seeing, and based on the pandemic, a corporate shift small to big to medium, medium to large, and we see a lot of companies, young companies of less than 30 years, going into additive manufacturing, digital services with a fairly good degree of success. So for you people in shipboard, it is very important for you to get in contact with these new manufacturers, because they're already exporting. And it may happen that we may know more international vendors than local vendors, but I think that it's interesting, it's important that any project that happens within our country will seek out the cooperation of those closest to you. And so, just like Jose mentioned, now is to work as a network is important. So how to work as a network. If we do not, we are not all going to achieve the effect of the impacts of the sort of which Colombia needs. Well, same thing applies to the shipworks. Thank you, Maria del Pilar. I'll take note of these reflections, because I believe that we are finally going to give it little by little a very good product of that good form. So I'll give you Miguel Garnica to ask you, the Navy, my dear Navy, is it ready for digital transformation? How's it doing? What are we doing? Mr. Admiral, I thank you for having asked it. We are in the midst of a change management process, in a process that will allow us to understand how important it is to jump ahead the sudden changes in our surroundings, and not only in national security and defense, but the integral, say, environment of it as a country. But a year and a half ago, a particle that we cannot see placed everyone in check. This had been foretold by Bill Gates in the conference late 2015, when he told us that what we needed to fear as a society, as humanity, was not necessarily nuclear bombs, but actually those particles that we are not able to see. And SARS showed us in December 2019 a rare disease broke out, which the world did not know how to control. We didn't act accordingly, and a few months later, catastrophes, destructions in many countries, practically world trade was affected, the survival of the human race was put in danger. And worth highlighting in the middle of all this, the fundamental contribution from the standpoint of international maritime transportation in order to support the subsistence of our countries, of our economies. And I say that because then the activity that our shipworks perform is so important. The fundamental shipbuilding activity, both for security and defense, but also for activities more in tune with commercial trade. And I'd like to highlight, of course, that big bet that is today consolidating the success. 21 years of great success, and which we hope to be many more to come. And this I take to the management of knowledge and innovation that is taking place within the Navy for the purpose of guaranteeing that innovation, which for the Colombian Navy, the Navy means not only an economic return, but a return on what we consider operational readiness of our units, the reduction of the cost of the life cycles of our ships, the development of the technological applications to support a force. And if we are capable of doing it well, this will surely bring progress for the country. Now, the 2042 Naval Development Program, it's important. It's a long-term horizon. Not long ago, I was reading a forecast study developed by NATO, where towards 2040, they identify 8 areas of technology that will be important in defense. All these technologies that we have talked about this morning are part of the framework of that forecast study: autonomy, artificial intelligence, data, materials, hypersonic, just to mention a few. Everything that deals with life. Let's not forget that not long ago, perhaps a year ago, a Nobel Prize was awarded to a researchers that allows one to now get rid of one of the diseases and it was change management. Innovation is important for the Navy because it points toward the integration of all the capabilities that we have as a force. A goals are set, a purpose for what we want to do, but starting from the strategic view that we have as an institution with a very clear audit on our knowledge, identifying early on who our strategic allies are, and without extending ourselves too much, what we found in the national science technology system, well, and innovation of our country, which but every university in Colombia, public and private, but also the private companies. We saw all those, and within that sea of opportunities, Mr. Admiral, will find responses to questions that today still don't have, or solutions to problems which still exist in our institute. And that is why, very judiciously, with a very detailed plan, we are walking toward that consolidation of knowledge management, but based on change management and the challenges that supposes. To fail to understand that would be as if insisting on building a wooden ship once all metal and ship were built and proven. So those changes are hard to understand, right? I mentioned strategic alliances a bit. Of course, I insist on that development plan for the Navy, a plan where the backbone is the technological development, but the basis are the strategic alliances, both national and international. It's pretty important because today no project is conceived in a single discipline. We are talking about projects where many areas of knowledge intervene, many areas, many institutions, and that allows us to supplement one another. Collaborative work is key to achieve many purposes, in this case for Colombia as a country. And in that sense, Admiral, any project that the Colombian Navy, together with the Maritime Commission, with the Ocean Commission, with the FCC forces and the universities, today we are betting on solutions for the country. A clear example, just to mention a project, the fluvial and rail electro mobility plan that is being developed by the Mining Energy Division of the Ministry of Energy and Mines, that is betting on a multimodal transportation program for Colombia, rescuing the river, joining it to all the capabilities that we have as a country, including railways. That last part, Miguel,
se conecta directamente con lo que recién nos mencionaba María del Pilar, y es que...
This is what María del Pilar said, the efforts cannot be isolated from one another. Efforts must be coordinated, and along that route, how is the Navy working? How are the Navy's training sessions working with the academia? And be very complete to close. Yes, I celebrate the attendance of the Dean of the Siemens University, because the 10 centers of instruction that the Navy has are perfectly articulated with the research centers, the centers of technical development of various universities in the country. What are we doing? We are availing ourselves of all the opportunities that the Colombian state gives us, the opportunities that MinCiencias provides us, but also other ministries, other entities such as the National Spectrum Agency, to obtain resources that will allow us to develop those capabilities that we mentioned a while back. And in that sense, the Navy's training school, which are higher educational institutions, are now capable of achieving projects not only vital for the court, but for the country. And that's how we're doing, Admiral. Teamwork is key to generate development. Progress, development with security in Colombia. Thank you. So, this is definitely a topic about which we could talk all morning long and a good portion of the afternoon for Jose Luis and Madrid. However, we have time constraints, and so if I may, I will make a brief synthesis of what is being discussed this morning. Of the interesting things that our panel members have commented on, and I'll start with something that we've already highlighted, and is that in the process, at the center of digital transformation lies man, the human being. And I think that that is something definitive in Colombia. I believe that many of Colombia's problems deal with the generation of opportunities, and you have mentioned it. Paola just said to give opportunities to young people, those who are starting out, with the startup. And Maria Pilar reminded us of that. Wonderful things are happening in Colombia that we are sometimes oblivious to. I must acknowledge that a similar scenario 3-4 years ago, I found out that ships, the most modern ships in the German Navy, the glasses were highly complex glasses. And by that I mean special characteristics that also had a film on top that could also be heated and would prevent them from being fogged out when the German ship would sail out to the North Sea. Well, those glasses are done in Bogota, and we didn't know them here in the Navy. And they were working here in COLOMBIAMAR, but they are the same who build glasses for brands such as Tesla, Mercedes. Again, glasses with high complexity. Clearly, we need to generate opportunities for our people, for our young people. And talking about that anthropocentrism, we were reminded that ethics is key. And that distinctive characteristic of a human being has to be taken also to the digital realm. But we were also talking about the need of accelerating the process. And Paola talked to us about the CID model, about which I will pick on the democratization. Maria del Pilar said that there were many opportunities on which we can work. We're working on the language cooperative processes that are available in the network. There are 80,000 opportunities of training, again, available in the network with the mechanisms that have been developed and which were developed in the pandemic and of which we need to avail ourselves. But democratization must be key in this transformation process. And as we said, it is an opportunity of, it is a highway of opportunities. A highway where we must travel at the speed that we are being required to travel at. And this cannot be just talking about future things that will come along the way, because that change is happening today, now. And we were talking about the technological change, but we today understood that it is not only technology that needs changing, we need to change the business model, and we need to change the way in which we think. That end, we need infrastructure not only in the company, focusing on my problem. No, we need an infrastructure in the country. We need to make communications cheaper, the hosting, all those things that are part of the technology need to be further developed and be further sensitive. And to rethink companies will be the challenge of managers. And we were reminded of that not once, but several times, that we need not be expert in a specific area, but actually understand the concept of what it is that we are applying, of what we want to bring to those companies. Because we have to think, managers do, in terms of ROI. What are we doing in terms of return on investment technology-wise? And talking about the challenge that Jose Luis posed us, we can't get lost in these technological processes where we implement things without the crystal clear clarity of where it is that we are headed and what it is that we want to do. Again, I go back to the ecosystem. Maria Pilar said, no, it is not only an effort of conciencias or inciencias. No, we are talking about technological convergence. And Maria Pilar reminded us that convergence also goes through the government entities, that the effort must come from the various entities in the government. And one of the columns in the model also was the private sector. What a huge responsibility the corporations have, Paola, with the generation of opportunities for people. See those startups that start, that they be accepted by companies, but especially that they've been supported by companies. And so we have to then review our corporate strategies, as I was saying, for that change to be effective, for it to add value, but especially for it to produce, to last through time. And in that sense, the challenge is then how to adopt that technology. The what, the when, and the how. And the question is, do we have the human basis so that when we acquire or transfer technology, we'll have the sufficient capacity to absorb that? So in that sense, I go to the university, and Paola talked about that concept, the cellular domain. We need to review the education of our people. We would need like 5 years for each. Do we really need 5 years for one of each of these careers? Surely finding things that repeat themselves, or which definitely have no place in today's world, let alone the future. And what if we start raising that borderline? Just like you presented the border between the social and the technological, and what we are being demanded today to do. So all of us have a tremendous responsibility to society. We are reminded of environmental, social conditions, governance. It's not only about developing companies. It's not only about how things are done, engineering, Mr. Engineer, but what value it contributes, and what value we hand back to society. So that in that critical architectural value for the global opportunity, Maria del Pilar mentions several of these, and she summarized them, to remind us again that the effort must be of us all. So I insist, and I want to close with the need to advancing all these processes, but with the people at the core, people in Colombia who need opportunities to continue to grow this wonderful country that we have. Now, for my peers in the panel in Bogota and Madrid, and those of you here in beautiful Cartagena de Indias, my thanks. My warmest thanks. I have learned a lot. And I hope that for those of you who've been attending and listening in, all these concepts might have been as nutritious as they were for me. Have a good rest of the day, and see you then.
Por sus aportes y toda esta discusión alrededor de las apropiaciones.
Okay, about the appropriations, the new technologies as they apply to digital transformation and enable the 4.0 enable industry. Based on that, we will enable 2 channels to have access to the technical presentations that we will have in simulcast according to the theme. So, competitive and the shipworking industry, you will be able to access today's program through COLOMBIAMAR 4.0.
Michelle, ¿sí me escucha?
Ustedes van a pasar para allá.
Muy buenos días para todos. Continuamos en nuestro congreso científico COLOMBIAMAR.
Everybody, we are moving on with COLOMBIAMAR 2001, and today we are starting to talk about Shipyard 4.0. Today we have Jean-Michel Chatelier from Bureau Veritas. Mr. Chatelier is a professional in shipbuilding of the Nantes University in France, expert in shipbuilding, classification, and regulations, as well as internal water navigation and fishing boats. He's a leader for internal waters navigation in Bureau Veritas, and today he's presenting creating a rule framework for the green revolution in the shipbuilding industry for internal and territorial waters. Good morning, Mr. Jean-Michel. Floor is yours.
Señor Michelier, excuse me.
Yeah.
Can you to activate your microphone?
Now it's activated. I think I don't know what's happened. It was activated, but it's been stopped. I don't know for what. So can you hear me now?
Yes, yes, I can hear you without any problem.
So I can start.
Excuse me?
I can start now. Okay.
Yes, start again.
Okay, so good morning, everyone. Apologize for the folk start. I will introduce a topic which is interesting for all industries, but I will focus on the shipping industry, of course, and especially for internal and territorial waters regarding how we can contribute to decreasing global warming. So I will start with a reminder on the challenge, the original challenge, I would say, and the new goals now, with the possible methods and fuels could be part of the solution with their associated risks, and what choice of technologies, also with what regulations associated to the risk, and a short summary in the end. So the challenges first. So originally, that's not new. I mean, we know already for decades that we have to avoid pollution. So pollution, simple for ships, so the waste management, the materials we use for anti-fouling, to fire extinguishing and so on, and the refrigerant, and also to prevent oil spillage. Well, all of that. So, apart from any national or international regulations, so Bureaucrats offer the classification notation clean ship or clean vessel for inland vessels. At the same time, so because it's been discussed at international level long ago regarding hazardous material which can be on board, so for recycling, but not only recycling, actually, for also in case of repair, in case of conversion of a ship, so all substances that affect safety of people would be reported in a document. So this also is covered by the notation green passport. And to avoid pollution, also it seems quite logical than to avoid the ship using their generators in harbor. It can be the solution to connect the vessel to the shore installation for electricity. So this is not new. We have also class notation, so for ships equipped for connecting on the shore installation, and indeed shore installation must be available. So now the new challenge, according to all international institutions at the level of the United Nations, is to make sure that we may avoid increasing the global warming less than 2 degrees, which is really a challenge, because this global warming, I mean, is due especially by the greenhouse effect, and it generates drought, increase in the sea level, flooding, pollution, and so on. So this is really the challenge now. So clearly, IMO, the International Maritime Organization, so puts the challenge clearly. So the purpose is to avoid, to limit, I mean, greenhouse gases, fixing limitation of CO2 emission, I mean, to reduce by 40% by 2030, and then by 70% by 2050. And globally, all the greenhouse gases reduced by 50% by 2050. So globally, the greenhouse gases, so they are mainly CO2. You can see that most of the time, everyone focuses on the CO2, but we have also methane, nitrous oxide, and other. So what is important to understand? So first, CO2 is also of natural origin, so the 76% are not all from human production, but only something like 5%, no more. But it's been sufficient to unbalance the weather and the equilibrium of the planet. So you see that there is a coefficient GWP, which is a coefficient, I mean, reporting the effect of, let's say, trapping energy compared to CO2. So, for example, methane, even if it's only 16% of the total, but anyway, the effect is 20 times more than carbon dioxide. And same for nitrous oxide, so it's 200 times more. So, and the rest, so especially the fluorinated gases, they are even 10,000 times more efficient, I mean, in the greenhouse effect. So there are many options to meet the challenge. So it can start, and we did already long ago, to optimize hull forms, optimize the propellers, also the coating and so on. Also a very large panel of solutions, but far behind the path to meet the goals now. So decarbonization implies to leave all fossil energy, and indeed it must be calculated from well to wake, and not only on board the ship, of course. So it's a complete chain. So to talk about decarbonization must be studied on the complete line from the production to the consumption. So it's very clear. So indeed, it's out of the ambit of naval architecture, but it must be kept in mind when we talk about possible solutions. So it must be a sustainable process. Simply, what is sustainable process means to find a way for coexistence of the biosphere and the civilization, to create a kind of homeostasis balance for the environment. So indeed, energy storage is one of the topics. So it can be in terms of tanks for gas or liquid, but can be also in the form of batteries or solid as well. Also, it's not yet ready. So shipping industry indeed has to do its part, because we know that transportation is one of the main sources of greenhouse effect on using green energy. So green energy means it's renewable, but also renewable, but not producing CO2, or otherwise it's not being considered green. So green is really with no effect. So all those possibility of energy sources are associated with technology, and they are presenting new risks compared to what we know for many years now. So a new challenge regarding safety. So the technical challenge can be converted into a regulatory challenge, because there is no regulation, no complete regulation now for all possibilities, all technologies. So for administration, it can be really a challenge to regulate, because the shipbuilders and the ship owners are waiting for instruction regarding what requirements must be complied with. And if the vessels are not covered by international convention, to fix the regulation for those new technologies. So I would like today very quickly, to introduce the main alternative fuels with the technology, with the major risk and the obstacles. I will refer to the classification rules because the purpose of the classification is to regulate, to fix technical requirements to ensure safety. So in terms of new fuels, we can divide them in three categories. So carbon fuels, so from fossil origin, so like LNG, LPG, methanol, what we call neutral origin, neutral, carbon neutral, because I mean the CO2 produced, emitted is compensated what will be avoided or removed in the consumption. So it's not really, it's not zero carbon, but it's balanced, let's say, and it doesn't produce more carbon than compared to using carbon fuel. And then the new generation would say the new possibilities, the new technologies using zero carbon like hydrogen and ammonia, provided, of course, that those products are generated with non-pollutant technology. So now, quickly, the possible methods on fuel. So the first one will be natural gas. That's the one we know for many years already, but it's especially methane, so from fossil origin. So there is almost no SOx, indeed, and it allows to reduce NOx and GHG emission up to, let's say, 20%. So it's not complete. The point is LNG must be stored at very low temperature, so minus 162, or it can be compressed, so we call it a CNG in that case, with high pressure, so 250 bar. So the main hazard we know very much because we know this matter. So the jet fire. So in case of accident, if the leakage is late, so it can be a jet fire, so which is of course very dangerous. The phase transition. So indeed, also in case of collision. So if the LNG vaporizes at the contact of the water, so it's a huge transfer of energy. And maybe the most dangerous for, I mean, considering naval architecture, so is cryogenic temperature, which can produce brittle fracture to the steel structure if it's exposed to a low temperature. So this is really a challenge. So petroleum gas is a mixture of propane and butane. So this gas is heavy, so that means in case of leakage, so it stays on the floor at floor level. It can be a solution, but it releases more CO2 than the LNG, and well, there is a decrease, let's say, in the other pollutant, but it's not a perfect solution. Safety aspects, so same indeed, the risk of fire and explosion. So especially because of leakage, the gas will remain at floor level. And it's also a toxic and dangerous gas, so regarding accessation. So methanol. So methanol, it's a part of the alcohol group, so where we can consider methanol, ethanol, but also propanol, butanol. Well, we talk especially about methanol in naval architecture. It can be interesting in terms of the octane ratio, which can generate better or increase power output, but it reduces CO2, it eliminates COX, but it's also not complete as a fossil fuel. It's not a complete solution with some safety aspects. So notably regarding reaction with oxygen, it's flammable anyway, and it's toxic. So biofuels. So biofuels are considered neutral. So it's there are many types actually what can be considered biofuels. They are produced from the biomass, means from biological organism. So it decreases GHG, notably methane and ozone precursors, so they are a long family of ozone precursors. So biofuel originally, so first generation was produced with special organic materials, so means by way of agriculture, but agriculture is also one source of pollution. So it's not very making sense to generate extra agriculture, taking room for producing food, and because of the fertilizers and so on. Well, the second generation is mainly using waste, or the type of waste anyway. And now the new generation will be to go to microorganisms, or like G. So there is also an evolution in types of what we call biofuels. So now we come to what is more, let's say, on the table, more recently on the table, like hydrogen. Well, hydrogen, yeah, it's interesting for energy. It's so we have a lot in the universe, but unfortunately not in natural conditions, so it must be produced. Transport and storage is really a challenge, because it must be either very much compressed, very high pressure, 700 bar, or liquefied but very low temperature, so minus 250 degrees. And we need, of course, a lot of energy to produce hydrogen first, and then to put it in a condition to be stored and transported. So we use only part of the, we need more energy, but when we get. Well, that's the problem. And indeed, the main risk is the flammability, which is very much the challenge. So ammonia, so there is no CO2, it's zero CO2. This one can be transported in, let's say, more easy conditions, low pressure or temperature, but not minus 30. But the problem with ignition is difficult. It burns not much good, so it produces also a NOx. Also, the density, energy density is low, so something like 3 times less than gasoil, so need room for storage. And the point is, the product is also toxic and caustic. So that means it's very corrosive, very corrosive. So that's also one problem of this material. So just a small table to summarize. So you can see on the left, so interesting data regarding mass energy and energy density and volumetric energy density on the far right column. So you see the volume needed by compared to gasoil. So you can see, for example, hydrogen, you need 5 times, because this is also not considering insulation. So for small ships or small tanks, so the percentage due to insulation will be important, and so the volume is a problem. Regarding risk, so also it's summarized in a small table like that. So you can see also fire explosion is for all of them. Pressure, so mainly CNG on hydrogen. Regarding cryogeny, so LNG on hydrogen as well. But, so the risk generated by such means of storage. So now I would like to pass different possibilities regarding technology. So just I would say that first, the regulation are not yet technical options. So, and also it's important to understand that the regulation, they are usually fixing the technical arrangement, but not the constructive disposition. So that means what about manufacturing, about what material can be used, and what about testing and construction of equipment and assembling on board and so on. So that's why the classification rules are, the solution, I would say, to fix the safety parameters. So in BV, so we have two main rule books, let's say one for seagoing ships, one for inland vessels, and a common set of rules regarding all material and well.
1 minute.
And because we started late, so I have to pass very fast. So first, thermal engine, so it can be used with LNG, and it's a choice for many companies today, with 20% of the order book using LNG. Different type of engine. No one is a real solution for the moment, and the problem is methane slips, which is indeed against what we try to do. There is one regulation for LNG, IGF code, and we have the classification rules with taking care of all the safety topics. Regarding LPG, there is no regulation. There is no regulation, but BV, so we propose a classification rule covering all the risk that we have been talking just before. So methanol, the problem is the rearing of the component of the engine. There is no regulation as well, but we propose a regulation, so we have a rule book for that. We may compose, but for the moment, so a composition between methanol and diesel. We have some project about that. Biofuel that we use almost always. The technology is same as the original fuel, but it must be difficult to do with oxidation and also cold flow. So, that's technical for the engine. So we used to have a reapproval of the certificate of the engine and so on. Hydrogen, there are different technologies. Nothing is very appropriate because of NOx. Depending on which technology we use, we produce NOx, so that's not the purpose, or the capacity of the engine is very much reduced. There is no regulation except for storage. The Reuters proposed a guideline regarding containment and use of hydrogen on board vessels. Regarding ammonia, so the challenge, so it's mainly the toxicity. So this is really a problem, and because of corrosion of the engine and so on. So we have a regulation for that. There is no international regulation. A GF code is not appropriate, but we have class rules for using ammonia. Fuel cells is very interesting technology, developing, converting in electricity, effect of hydrogen reacting with oxygen. We can use different type of fuel because there are many types of fuel cells, can be used directly hydrogen, but also LNG and methanol. In that case, indeed, the requirements regarding the basic material must be followed. We have a class rules regarding hydrogen cells, different type of hydrogen. For the moment, the problem is if we increase the temperature for reforming, the INOC is very long. You see, it can be up to 10 hours on the last line. So it's very big thermal inertia. But it's permitted to probably some success. Batteries now, indeed the point is we have to charge the batteries, so it depends where the electricity comes from. But the technology is improving very much, especially now with lithium batteries. But there is risk, and notably, it must be well managed by the battery management system, which is really a part to manage and to avoid thermal runaway, which is a major risk on battery, and it's very important. So we have the class rules for that, because it needs really serious examination. and we start with a risk analysis. All hybrid systems, so hybrid is generic, so we can hybrid many things. Usually we talk about a combination of diesel electric system coupled or not with battery system. So there are many topics. It can be interesting for conversion, but indeed we still use thermal engine, so it will depend with what we use a thermal engine, if it's diesel or if it's a biofuel, for example. So just to summarize, so you see there is a large panel of solutions, but no panacea. So all will depend on the type of vessel and the constraints of the area of operation, notably for bunkering and so on, or regarding the risk and the type of fuel and so on. So LNG, LPG, methanol, well, for the moment, biofuel, probably it will be never the solution because it's used in our industry as well. And you see, we have to start from biomass, so it's there is a limit to that. So it's not possible to be really a solution in the future. Hydrogen, the risk is very high, but could be. Ammonia can be promising, but also it's an hydrogen carrier. Batteries are improving a lot, and they can be combined with fuel cells, and this would be probably a very interesting technical solution to allow to combine, I mean, the possibility to take the peak by the battery and to use the fuel cells. And all kind of hybrids could be used in between. So this is a very summary. You see many red, I mean, a pink place. That means there is really a problem. In terms of regulation, you see that very many solutions with no regulation. We propose, and we are working closely with the manufacturers, ship owners, and so on, to develop the regulations. And just to finish, I would like to say that we're in 2021. We have been reminded by IPCC that it's really high time to take measures, because you can see that this year has been really an example. The weather is changing, the global warming is accelerating. 2030 is almost tomorrow. 2050, we will see what we have done today. And today we are going very like the turtle, and due to the situation, indeed, we have to shift to a more speedy step to the solutions. And indeed, the regulation is very important to ensure safety of the new materials, I mean, the new technologies, and not to decrease the safety, of course. I hope I have matched with the time, and I thank you very much for your attention.
Muchas gracias al señor Jean-Marc.
Thank you very much, Mr. Jean. There is a question in the chat. The question is about the marine hydrogen. What type of toxicity and what risk does this fuel have?
What kind of toxicity and what is the risk of the use of this element?
You mean what risk with hydrogen?
Yes.
Yeah, but I pass fast. But I mean the material itself, with the flammability and the necessity to store with very, very low pressure, very low temperature or very high pressure. So we know the risk of high pressure on the cryogenic. And also there is, if we use in a thermal engine, there is a lot of problem of corrosion. There are different effects of the hydrogen with carbon, and so it damages the engine. So I mean, it's a challenge, and probably the best way is to use in fuel cells. That's probably the best way, but for the moment also it's a challenge. Well, I pass fast, but for the moment it's quite limited to small power, so it will increase in the future, but anyway, the risk regarding hydrogen will remain. I mean, regarding carriage, and also there is a question of cost, and if we go upstream to shipbuilding, the point is, I told you, so to produce produce hydrogen, and then the energy needed to make it ready for transportation and use. So that's the process today is probably not a solution. Storage in solid storage, but for the moment, so the technology is really not appropriate. So it can be a solution for the future if we can find a better way to store hydrogen in a solid way.
Okay, thank you so much, Mr. Jean-Michel. Thank you for your participation in this event. Thank you.
Thank you very much for this opportunity, and thank you once again. Thank you, everyone, and have a good day.
Buen día para todos.
Hola, buenas tardes o buenos días. ¿Qué tal? ¿Me escucháis bien?
Hola, Rodrigo, ¿me escuchas?
Sí, perfectamente, Carlos. ¿Qué tal?
Un placer, un gusto.
Sí.
Vamos a empezar.
Cuando queráis. Voy a ponerme el reloj.
Continuamos con nuestro ciclo de ponencias en el bloque de Astillero 4.0. En estos momentos nos acompaña el doctor Rodrigo Pérez Fernández de la Universidad Politécnica.
We now have Dr. Rodrigo Fernández from the Polytechnic University of Madrid, CAD-assisted design, 4.0 industry, artificial intelligence. He has a master in 2007 and a doctorate degree in 2010. Naval engineering from the Polytechnical University in Madrid, where he works as a teacher since 2013 as a teacher. In addition to his academic experience, he has a wide private sector experience. Today, he is with us with a presentation titled How to Improve Naval Construction with the Internet of Ships concept. Welcome, Doctor. The time is yours. Thank you, Carlos. Good morning, good afternoon, everyone who are here with us in this fantastic meeting of Congress. And the purpose of this article is to go into the 4.0 industry on the hand of the most advanced technologies, the Internet of Ships, which is nothing else than IoT applied to the naval sector. This technology is also enabling because there are part of the 4.0 industry which would have no place today were it not for the direct interaction with the iOS. For instance, the digital engineering, the on-cloud calculations, or enhanced reality. This has become the backbone and a large part of the implementations of iOS in the current industry. Something as common as the barcodes were responsible for this technology and have been the causes that many who have jumped to intelligent labels, which help them perform inventory as well as the collections of the various things they have. For instance, a jacket may be controlled by the system. The iOS, of course, is well supplemented with blockchain, and it is necessary as a base technology for its development within what we know as cybersecurity. Now, to think about how to improve naval shipbuilding with the iOS, we need to explain what the 4.0 industry is. We got to go back to its history to then expound about that Internet of Things, to then ultimately come into this latest concept of iOS. And now to understand how Industry 4.0 has become a word in vogue, a look at its predecessors could give us a perspective of how this revolution in particular is different. First industrial revolution appeared in England, in Great Britain, to introduce machines, with a certain rate of production. So 1760, 1840, and this went from going to manual labor to steamships and water as a source of power. This helped agriculture a lot, which produced a series of industries such as the textile industry. To further develop the textile industry in such a way that it contributed to an increase of the British economy at the time, the second industrial revolution, which goes from 1860 to 1840. Although from 1860 to 1940, though some say 1950, introduced telegraphs, railroads within the industrialization that had already started during the first revolution. Perhaps the marking characteristic of this period was the introduction of the mass production as the main means of general production. The intensification of factories increased production rates. Mass production of steel, for instance, helped introduce railroads in the production system, which, or as a consequence, contributed to the production and the mass production. The third revolution is more familiar for us than the rest because most of the people alive today are familiar with the industries that rely on digital technologies and production. However, the third industrial revolution is dated between 1950 and 1970. Oftentimes, it is referred to as the digital revolution, and the change, there was a change between the analog and mechanical systems to digital systems. Others have also referred to it as the information age. The third revolution continues to be the direct result of the development of computers and information technology and communications. The fourth industrial revolution implies the automation of manufacturing processes, and it takes them to a new level by the introduction of mass production technologies that are personalized, which are flexible. This means that machines will operate independent from each other and will cooperate with humans in the creation of a production field geared toward the client, working constantly to maintain that distinction. Machine becomes an independent entity capable of compiling data, analyzing them, and then advising us on that. This is possible by means of the introduction of the auto optimization, cognition, and personalization in industry. Manufacturers will therefore be able to communicate with computers instead of operating them. All this will be possible through the iOS, instance of the naval sector, and IoT in a more general sense. The transformation of the 4.0 industry implies an enormous collection of interrelated technologies that can analyze each other independently, but can be analyzed independently, but which must be applied as a whole in each of the industrial fields, and always from the computer-assisted design, what we define as TAC, manufacturing TAC, and consulting and engineering. I will talk about that as CAT within the software development industry. The technology is a set of limits that cannot be differentiated from its neighboring technology. For instance, increased augmented reality are closely linked to the digital twin concept that interconnected with big data, which is produced by these CAD tools and all these solutions in the vicinity, which implies some cloud computing of this data in a technology merge between machine and cognitive processes that provide to us by the artificial intelligence to be able to more agile, make all these computations. We require a network that supports different paths of connection to add electronic devices, special devices, for instance, the Internet of Things that may access data, creating them, modifying them in a different phase that may affect a basic information layer created by software within. This network must be secure, but also open to allow for distributed work, which must be controlled by a series of steps that record any modification on any of the elements that we may gain access to, or for instance, all those actors involved in that process, from the shipworks to the technical offices, the classification offices, the ship owners, and blockchain. Now, the result of the design will be easily integrated with future manners of manufacturing, like, for instance, the 3D printing, generating requests from the software, from the CAD models. The naval construction engineering phases imply, as we all know, the design and the production, but also a CAD system must be integrated with a 4.0 system to participate from the operation and maintenance layer. Basically, when a ship comes into port for repairs, oftentimes the model is not ready. So it would be good to be capable of having a 3D model as generated, for instance, through a laser scan or any other element, where we may quickly obtain the information to generate that 3D model. Now, I'm reviewing all these technologies gives us an idea of the magnitude and complexity that these changes are demanding from this 4.0 industry. In most cases, this is an unavoidable step which must be taken to continue to be competitive. But by adopting a single element of those presented here is a complex and risky step before making any decision. Any of these technologies are still in early implementation stages, but it's important to know and analyze what each can offer us. Basically, most technologies, as I present here, in the case of this conference, the most important is the iOS, are well known. But the true potential, as we have seen, came via the improvement in the infrastructures of communication. That is why the concept of the digital twin is something that appears within grasp today. With the 5G, we expect iOS to grow exponentially, and then we'll see its true potential. That will also imply a push to the rest of the technologies that we have seen. Basically, we can state that the combination of the wireless with the integration with the cloud this will be a turning point, because this will solve problems that we have still not been able to solve adequately, which has posed obstacles for the evolution of future ship works. 5G requires flexibility. But what are the advantages that this technology, 5G technology, will give us? It'll give us enhanced speed, broadband, improved more capacity, up to about 100 times faster than 4G. Ultra reliability, which could be a latency period below a second. Machine type mass communications, which can support a high number of devices, a more open architecture with third parties via the APIs, and also a network slicing, which is a concept that consists of a partition of a physical network and multiple virtual networks, each optimized for different applications, which could save costs and then have a faster time to market. According to the latest report, the number of connected devices by 2021 exceeded 46 billion. In comparison, it's an increase of 200% with respect to 2016. Many more will come faster, and it appears this year and next year. That is where we will see the final takeoff of 5G. This revolution, which started some years back, has awakened enormous interest in every industry within research departments and universities, and in some, it is already normal. Then the deployment of this 5G will exert great impact on IoT and iOS, linked to robotics and automation, virtual and augmented reality. Today, it is hard to buy any TV or stereo or telephone that doesn't have a connection to internet. In Barcelona, we saw that the main trend of iOS include intensification of forms, artificial intelligence. And this concept is, how is the naval sector adapting itself to the revolution? The question that we can ask, is it possible that this sector, so traditional as it is, so conservative, move toward this technology quick enough? Maritime transport is facing a new horizon. COVID, even with the recommendations by the OVID, has affected the sector logically. The changes of the creation of world value chains make an IoT concept to gain greater importance, and the result will be significant progress in the digital era for this sector. The social distancing measures, prevention measures, make essential the use of every technology that we've been adopting in the last 4 years. Cloud computing, cooperative tools like the software of conferencing that we are using today, Zoom, project management, chat, remote access to computers, synchronization of devices, VPN, and mobile applications. There is evidence already that the naval industry is no stranger to these developments, and it's already connected. And some components of the ship is already connected to the internet. Just like we have some in our home, there are new intelligent ships that are equipped with a network of sensors that capture a variety of sources from the project: location, time, sea current, the condition, the status of the equipment on board. Ship owners can monitor the status of the ship in real time and then regulate the analysis on the historical data and current data to be able to make decisions that allow them to operate more efficiently, saving both time and fuel. Now, the sensors technologies facilitate the introduction of new applications at sea, as the distribution of energy, the control, the treatment of water, monitoring of equipment in real time. Sensors that, for instance, pick up information on the quality of air are connected to an artificial intelligence system which can activate or deactivate the HVAC system as necessary. The purpose is to avail ourselves of this technological revolution, but acting on the basis of design and production in order to construct efficient, safe, and sustainable ships in a sector such as the naval sector, where oftentimes engineering are found in different construction are in different places, and where critical decisions cannot wait for the internet of ships or the connection through the connection of critical components. You start seeing as something that the sector cannot obviate. The idea is to monitor all those parts where the early detection of situations will allow us to make correct decisions. In this sense, to have available sensors during the first stages of the construction of the ship will allow us to identify whether the construction is following the design as we have created with the CAD system, that we can reduce materials or use others, if we should adjust something according to the naval architecture calculations. The construction process generates much information and data. So that leads us to think that it would be impossible to have all that data in real time. But the processing chip smaller and simpler with a good connection to the internet will make that possible. However, data management is only one side of the iOS coin. The energy efficiency is a fundamental aspect also in the new devices that are connected to the network. But that does not cover only the design and production stages of the ship. Once the sensors are part of the component, the information that we will monitor will come to us throughout the life of the ship. The thing is to detect a solution capable of detecting when a ship is close to failure and must be replaced. When, for instance, when we should take the ship in for repairs, when we need to paint again, when corrosion has reached a certain limit, and all this from our pocket tool or with sufficient time in advance to prevent us having to react. And that comes into our sector to ensure profitable production, an efficient and sustainable process for every kind, right? Tugboats, petroleum ships, even military ships. The two questions that we can ask ourselves then is, how could this revolution affect the naval construction world, and how could we consider this iOS concept, right? The projects are developed with CAD, as we've seen, but every day we look for an integral development of a product involving its entire life cycle. Our intent is to integrate the CAD system with the 3D system with a life cycle tool and be able to get from this PLM all the design and control the production and even the use of the ship. The PDM can contain information on every ship service and of every component. If components are designed for iOS, they will have technology that will make it possible to share its condition and its diagnosis with this system that is distributed. This lifecycle manager can use this information to know whether the components are working properly or whether we can improve its performance. It is also possible to identify the necessity of maintenance or whether we need to replace because its life came to an end or because it is working improperly. It will be possible to determine and evaluate performance by comparing it to other similar components and comparing different operational periods. It will also be possible to know how that performance affects the operation of the whole, such as, for instance, in this case, the complete ship. Also, the connection of objects is done through a lifecycle manager. It would be possible to record its historical data, follow up on its changes, and know what the function or performance is after having done the scheduled maintenance. In the case of ships, this kind of activity will include its commercial activity to act autonomously in the conditions of operation. A commercial ship can transmit its navigation condition or load condition. All this means a lot of information to be managed and analyzed. We must develop new software, new programs that will achieve the greatest use of this information so that design of the ship is improved based on the real information from the design as it exists in the cloud, and then create a method where objects may reach or attain certain intelligence. The growth of iOS is getting to the piece of information and the management of big data with the caveat that the iOS identifies information, direction, and order for a specific purpose, whereas the concept of big data is more generic. Now, the possibilities are endless, but the principle is the same. It's to start in the initial design, and it is necessary to consider what is required to fully meet the requirement of the atomic mission. This must be configurable from the beginning, and it is to be extended to the relationship of each with other systems. The CAD systems is one of the first steps, because it is where we start systematically compile the concept of each component. That is why it is necessary to use CAD tools to perform the design for the Internet of Ships. Therefore, we can say that by dividing each system in autonomous iOS, self-regulated, interrelated cells or services in the ship, we can reduce general failures in the system, and we can prevent from another part of the ship that are not directly related with that service. Cooling services can be divided in cells belonging to the corresponding service as follows. And this is just an example. C collectors, main pump group, secondary pumping, auxiliary pumping group, main motor circuit, discharge and marine water, and general control services. Therefore, for ship services, it will generate inputs for other parts of the system, and globally, it will be able to group all the parts of the services at the control room, where the general control of the system can show in a very simple manner the condition of each iOS cell, and also some data which may be distributed to the main console of the bridge. This way, each general control of the system is governed by the iOS. It represents an organ of the body with the summary of all the cell that's represented with this information always shared. Each organ has a relationship with the rest by means of this general control of the system. And continuing with our example, the complete failure of a cooling of the refrigeration service can communicate with the fuel and lubrication system, halting the main engine to prevent a greater damage. Also, this information can go to the main bridge to trigger an alarm, send a report to the shipbuilder owner, and then communicate via GPS with the closest port, waiting to receive any of the spares that we may require. With all this information, the control room engineers can start with the repair process or wait and see if the problem can be solved with the materials and the tools that remain. Now, understanding this biological concept of cells and organs and services of ships, any system that may be directly or indirectly related to propulsion may be an iOS system that groups all the organs to produce a simple action in the ship. The creation of these larger groups help us classify Earth's problems and also to improve maintenance, because each simplification requires a shorter list of spare parts. Basically, with these systems, we are generating what we currently know as the digital twin. And I've been on for 25 minutes. Thank you very much. And we're open to your questions. Thank you, Rodrigo, for the presentation. We have a couple of questions in the chat. The first says, how does the internet affect autonomous ships? What considerations must we take into account? A very good question. Well, there are two topics here. we are mixing complexity. On the one hand, we have autonomous ships, and on the other side, we are talking about introducing IoT tools to the naval sector. That is, it is not necessary for a ship to be autonomous for it to have these features. The simplest thing is for us to start applying these technologies to what we know as the current ships, and then go into autonomous ships. Because, of course, and this is a very personal opinion of mine, we are not going to have full autonomy in ships until many years from now. At least I believe, 10 years, we won't have a wide fleet of autonomous ships, and this is mainly due to legal aspects. That is, who insures those ships. But in response to the question, we can say that for a ship to be autonomous, it must have these technologies on board. And the question we can ask ourselves is, how can we manage this Internet of Things in a ship that normally, as we all know, the main material, construction material is steel. Especially they are trying that electrical systems to manage that Internet so that there won't be any lack of connectivity problems. So logically, something that we must all be clear on or about is that each stakeholder, every actor who participates in naval construction, if we do not all cooperate and talk among ourselves and connect, none of this will be possible, because we may have the biggest technology applied to the ship, but if there's no one in the port who is able to read that information to then be able to help that work, then of course nothing will be viable. But in response to that question, any autonomous ship will have this information, this technology on board, and the fact how it is, technically speaking, Internet is developing through electrical system in the ship to prevent the connectivity problem, given the material with which ships are built. The other question is, how do you control this operational information of sensors? That is, where do we center information, and who governs security? Again, a fantastical question. There are several. But first, let's start with the last. Who will govern this information? The British say, who is going to pay the deal? Who is going to manage this? Normally, in other industries, such as the aeronautics, it is the owner, the airline, manages all that information. In the naval sector, since building a ship is as if building a city, we have so many suppliers that it is so hard to say that the ship owner should control all that. Logically, the ship owner will have all this information and manage it. But now, this information must include security, because of course, even though it may be a trade ship, you need high levels of security. It is necessary to manage the security, and there are technologies already that are capable of managing it in a concurrent and or distributed manner. Another question we have is, how are we going to manage all this information? Currently, we are not capable of grouping all the information as supplied by these sensors. First problem, we are capable now, and there are engines, there are equipment fittings, accessories in the ship that have to be fully sensorized and which send us information. There are manufacturers who can give us a driver or main engine sensor, and also give us technical support where that information resides. Now, what is the problem we have currently in the naval industry? We are not capable of connecting all those millions of data in a single place. That will be possible in the future, but for that, as I said before, it is necessary to cooperate us all, because if we each keep information to ourselves, if we each work with a form different than my neighbor, we will hardly be able to achieve this digital twin concept that we are so hoping for. Thank you, Rodrigo. One last question, this last minute. These systems, iOS, are being validated by classification houses from the design. What is the current status of iOS from the commercial standpoint and in terms of development of these sort of systems? Again, a very good question. Basically, everything that regards this area are functionalities and technologies that are just starting to be applied, but with small steps. That is, we cannot say that there are off-the-shelf products that we can start to use. Certainly, there may be things, but it's only small pieces of this bigger puzzle. So on all this technology, developments are being made, neutral developments, elements. The problem is not the technology, the iOS technology. It exists. Neither is the installation of application of sensors. But the problem is to communicate all that information currently, because in a way, ship owners on the one hand, shipbuilders on the other. Well, that connectivity is hard. The total connection is hard. In fact, currently, it is hard for a ship, a works to deliver to the ship owner the 3D model. On very rare occasions, that happens because the intellectual owner is the shipward, and it will not assign it to the ship owner. And if it does, it'll be in consideration for some money, which the ship owner may not be willing to part with, because the benefits are yet to be seen. All this that we are seeing is facilitating this technology, not only for the initial detail and production design, but fundamentally for the operation and maintenance of the ship. So the work needs to be done, and I believe that we are all a party to this informing, teaching, engaging every participant in naval construction, and that this is the future. And if we want, as I said during my presentation, we want to keep ourselves at a level so that we may continue to be competitive, and we need to implement these tools in our sector, which, as we know, has always been very traditional. And in many cases, we have introduced improvements in other industries. In other industries, those improvements had already been adopted years ago. So thank you again for your participation. We hope to have you in other conferences. So thank you. A pleasure.
Hola, hola. Sí. No me deja encender el video, dice que... Dice que no puede seleccionar mi cámara. No sé si tenga... Espere un momentico. Ve, no me deja activar la cámara. Voy por otro lado. Seleccionar otra cámara porque... Uf. ¿Qué pasa? Voy por otro lado. Hice pruebas ahorita y estaba todo bien. Ahora no vas a iniciar la cámara. ¿Qué pasa? Bueno, voy a cambiar de computador. Cambio de computador y me conecto en otro computador. Permítanme. ¿Por qué no me deja activar la cámara si estaba? Hago pruebas acá y hago sin problema. Voy a transmitir desde el celular entonces la cámara y la presentación la hacemos en el computador. ¿Cierto? Sin problema. No, necesitan las dos cosas.
Señor Carlos, ¿me escucha? Señor Carlos Rodríguez, ¿me escucha?
Sí, yo te escucho, con un eco.
Pero no me funciona esta vaina. No me deja iniciar la cámara. ¿Por qué?
Señor Bachir, ¿puede activar la cámara, por favor?
Es que no me activa la cámara. ¿Por qué? Ok. No me activa la cámara.
Doctor Sergey, ¿es posible que usted vaya iniciando la presentación o las temáticas tienen que seguir una secuencia?
No se le escucha al doctor Sergey bajo, por lo menos yo lo escucho bajo, no sé ya cómo lo escucho.
Voy a conectarme.
Comparto la pantalla. Señor Sergey, porfa, ¿podría hacer un poquito la voz para que se escuche un poco más? Para escuchar más fuerte. Hola, ahora sí. Perfecto. Ok, entonces empezamos con el señor Sergey, su presentación, y hasta que el señor Bachir se acomode con cámara y presentación. Ok, cuando quiera, señor Carlos.
Continuamos con la serie de ponencias del bloque temático Astillero 4.0.
Moving on with the presentations of the event, we have Mr. Sergey Lonin. Next, we have enhancement of capacities under the Francisco José de Caldas Fund, focused on USVs and alternative use of energies in Colombia, and presented by Mr. Sergey and Jakub. Mr. Jakub, he is an expert in automation and a master's in education from the Simon Bolivar University since the year 2000. He's acted as a full-time professor, and today he's a defense instructor in the Almirante Padilla School. Mr. Sergey Lund is a doctor in physics and mathematics, expert in surface water and applications of numerical models and processes of turbulence in surface water, sediments, and contamination derived from transportation. Nowadays, he is a professional leader in the investigation group of the Almirante Padilla Naval School. Good morning, everybody. I'd like to thank the organizers of the International Congress, for giving me this 15 minutes. We'll talk about the use of alternative use in the specific case of keys in the sea flower. This is a problem that was born from other projects that we had before with Conciencias, funded since the year 2016 and 17, and we never thought that it was going to be related to alternative energies. Anyhow, the presence of a national navy in the Keys of a sea flower reserve is very important, fundamental for the country, and that could be reflected in the control of drug trafficking, illegal fishing, in SAR operations. So this is a Coast Guard platform in the keys Albuquerque or Serranilla, etc., in the several keys. There we can opt to have a YACAP system. But its autonomy is going to require alternative energies because, first of all, we're talking about the ecosystem. We want lesser impact on ecosystems and also to have enough autonomy based on possible energy sources. We know that the research group is considering this, while in the Pacific, the tides and currents are so strong that they're capable of providing energy to full towns. But in the Caribbean, we don't have that capacity. So the alternative of solar panels and waves and currents energy, this is what we have found here, and I'd like to share this with you regarding the use of currents that are formed along the barrier walls in a specific case. So the project started from the wave and currents that we see in San Andres Islands, and then you can see the orientation of the tide on the left. We have that no eco measure can go through that. Our first task was to draft a model through these remote sensors. What is that we are studying? Back then, we were studying the tide and its adaptation based on the marine weather that is apart from what I want to mention in a moment. However, when we talk about the model, this is the methodology that can be developed for each keys or island. This is the empirical models that are known in the world. On the right low corner, you can see a model drafted for the Serranilla key. This is something that was funded by the Colombian Commission of the Ocean. So this is the questions we asked. And this is part of a methodology in how to arrive to build a bathymetry in those very low and very shallow waters. And then we got directly to Albuquerque case where we can see a very significant coral reef. So on the left, this is the image, and then on the right side, we have this embedded image, and then when we go deep, we can then relate to the coral reef, and with the aid of a hydrodynamic model, which is our own model, that we can classify all these initiatives. So I'm skipping this part of the model. This is not today's discussion. So this is a model that we have considered with the Ministry of Science. Here below, you can find all the formulation and formulas of these model. This is the one that receives the satellite image with a atmospherical and astronomical precision, and with the light reflection and attenuation in the water column and dispersions that we can get. That's how we can get the depth of waters in this case. So I'm skipping this part here, and this is some of our results. On the left side, we can observe an image, satellite image. On the red band, and the other data. This is how we can draft the bathymetry, which is on the right side. So this is a part of a methodology that has to be conducted for each key and island. Anyways, this is Albuquerque again, because the days is San Andres and Albuquerque, so we can see how the image looks in a red band. In this case, so the job is to establish the bathymetry through this image. This is the shallow water theory, where the main band is not even wind or tide, but the micro, not the micro tides, but this is forces induced by the breaking of waves. So this is some of the formulas of our model. So how do we do this? What's the methodology? So based on this data analysis, which is 2 or 3 decades of information from deep waters. This is the period, and this is the depth. Here we have the waves representing the possible directions. Here we get into the study area, and then we see the results of deep water wave proportion. This is the bathymetry that we used. In the first domain with a low resolution. Here we can observe on the left upper side, this is height of the wave and length. What we can see here is that we have a breaking of the waves over the coral, and that's where we will get the induced currents. How important are they? Why is it that we are having this conversation today? If we go back to this third domain, this is the function of a current that indicates the movement of water. And so this is window number 1. So if we take the currents from there, we observe that currents produced from the waves, it's a jet of water that stays. In other words, if a platform gets there and installs outside the reef, and there is concentrated energy in this jet of water, it is going to stay there during the break-in. So here I go back to the San Andres area to observe the dynamic of this jet of water along the barrier. And on the right side, you can see clearly from north to south along the barrier from Johnny Key to San Luis. And this jet or current, to give you an idea of how it works, it is 2 meters per second of nearly permanent current and a flow of 100 cubic meters per second. So this current represents all the energy of the waves concentrated in one area of the sea along the coral barrier, the reef barrier. So this is a significant source of energy that can be used. And for each coral or reef barrier and all the locations at Seaflower can be leveraged in an important way, even more important than the wave energy that's very much spread. So I go back to the previous figure. This is how the current looks. So the project is the characterization of a morphology of a marine bottom and its relation to the ocean physical processes.
Continuamos entonces con Bashir. Adelante.
Buenos días.
Mr. Bashir, good morning. Can you hear me well?
Escucha bien.
Bueno, buenos días. Muchas gracias por
Okay, good morning.
pequeño percance técnico. Iniciamos esta presentación con
We want to start this presentation by referring to the Francisco Jose Caldas Fund. This is a research and development fund in Colombia. So through the agreement with this fund and through the alliance of National Navy and the Ministry of Science and Technology, we've been reinforcing our research efforts in the National Navy, especially in the Navy School, where we have 9 projects on the way that are very varied. For example, regulations in maritime rights and law, combat and simulation. So with this opening, start my presentation, which is focused on the development of a strategy for the SUVs.
Lo que pasa es que la presentación aparece corrida para que la desactives y la vuelvas a compartir, por favor.
Okay. Veamos qué pasa. ¿Qué pasa?
Colocándolo en modo presentación.
Sí, es que no sé qué pasa con estos. Bueno, listo. Vamos a ver si ya es lógico. Confírmame.
No.
¿No? ¿Me confirmas?
Ahora sí.
Ok. Entonces, nuestra ponencia está orientada a los vehículos de
So our presentation is about the unmanned surface vehicles. These unmanned surface vehicles are widely used in the major countries in the world. They can be used in war missions, anti-submarine war, surface warfare, intel, and recon. So this has made them of high interest for the Navy to start developing this type of technology. These USVs are in the development phase. There's still no industry that can produce this type of technology in bulk. So it is of high interest for the Navy and the Navy school, where the officers are trained to start education since the early age to develop these type of technologies. Likewise, for COTECMAR, this is of high interest because it is the corporation that deals with the construction of these Navy ships. So how do we start this research education strategy involving students so we can enhance and build capacities to build this type of technology? So we have this institutional framework. First, the Navy, in its objectives, in its 2042 plan, proposes to produce autonomy to reduce technology dependence. It also dictates that the degree papers of these students must be focused on solving this issue. And it's also a requirement for the students to graduate as electronic or naval engineers. So under this framework and in a more education perspective, we reinforce this strategy through in room and school activities where we take those subjects and connect them to these projects so they can be executed and complete the project successfully. We also have lab tests and simulators, and we do corporate visits to Navy companies or the private sector. We also do practice in Navy ships and also private companies that have container ships. We also do continued education. We run conferences, courses, seminars, and we have experts supporting the students so that the students can get the best help possible. We have different actors that participate in the sector. This joint work between universities and the state is crucial. So we have the Ministry of Science and Technology. We have COTECMAR with vast experience. We have Petty Officer School from Barranquilla, DIMAR, COH, Direct. This is one of corporations with whom we've had joint projects. So we have this the Proyecto Buque. This was funded by the National Navy, and it was about the design of a ship for instruction and training, led by Roberto Carlos Angel. So at that moment, that idea was taken to the classrooms, and it was proposed as a project to design a ship. And then they started to apply all the technology and methodology of Navy design. So the students started to design this type of ships that by building these prototypes to show that they were applying what they were learning. So these holes, these prototypes were piling up in the laboratory of naval architecture. So we saw a way to apply this. So the best way was to take those electronic engineers to endow these small prototypes of with hardware for heading and then radio links for remote control, and that's where we got the first prototypes of the academic level. Each team applied their own methodology to build these ships, like the design spiral, and the electronic engineers apply a similar methodology that is used to develop electronic systems. Right after that Buque project, once it was consolidated, we saw that we were able to participate in the Hydro Contest event. This is an international contest that takes place in France, in Switzerland. It took place in 2013. Its purpose was to foster energy efficiency, and it gathers students from all around the world. So we saw the opportunity to present our products, and that's how we put together the first work teams. So We had students from the engineering school to design the hulls and participate in different competitions that had three categories. One's the regatta for feed and cargo transportation. So it had the same engine, the same battery to all the teams, and the philosophy of the team was to make that battery to last as long as possible. So first, we had the electronic engineers to design the hardware, all the comms hardware, and also we had a student from the Universidad Nacional and mechatronic students that were able took care of the navigation control. So that's why we put together, or that's how we put together the team, and then we designed the first prototypes. We worked with a trimaran, then catamaran, and then in the years after, we improved capacities through other papers the students apply to the development of a vessels. So in this way, the last contest in 2018, we brought a better equipped prototype with better technology, with more studies and better improvements to find that efficiency that the contest was after. Then we have the Savalo project. This is the National Navy project. We had these two boats equipped with hardware to operate in riverine and marine settings. So in the lab, they worked perfectly, but when they were sent for testing, results were not that good, and we had no way to intervene them because we didn't know that code. The software was like a black box to us, so it became a challenge. And by having all that maturity that we had gained with previous projects, we proposed the Caldas Fund to develop the navigation control system. So we were able to develop the first control system. This project was successful. So we proposed a second phase to scale it as USB technology system to implement it in the strategic surface platform that the National Navy expects to have ready. Likewise, the students participated with their papers, and they were endowed with more technology. So the new the USVC system has the Campacriova national instrument brand operating in real time with a huge capacity to connect different ports and actuators. It's got telemetry systems that could be monitored, balancing, tilting, magnetic orientation. It's got IMU system, GPS, and cameras to have the horizon of the activities that the vessel can perform. This is one of the results achieved. More importantly, both in the Hydro Contest and Savalo projects, here we want to highlight the personnel trained in the Buque project. We trained 77 students. We had 77 students participating, and so they're there so that they can continue to develop that once they become a part of a Navy. In the Hydro Contest, we had 20 students, and the Savalo project so far we have 12 students. I want to highlight that the Savalo project is ongoing, and what we intend is that we can build a prototype demonstrating the technology so that it is possible to implement it later on for the National Navy. So the project is focused on enhancing the comms links, given that the riverine marine setting is not easy to keep that comms up and running. So we are also intending to integrate that to the Navy network. So the Savalo, the Hydro Contest, and Buque project, we have had also the participation of the COLOMBIAMAR, National Navy researchers, Petty Officer School from Barranquilla. We have had entities like the Ministry of Science through the Caldas Fund. We've been able to do presentations. We have had students traveling abroad, which brings students to a more competitive and real setting. So this is some of a media coverage that highlighted the Hydro Contest project with our students in that international event. And down below, you can see the coverage on the Sábalo project, highlighting the development of this vehicle for Colombia. Some of the recommendations are that in order to continue this development, it's crucial to connect the private sector and the government, the state, given that funds and technology support and experience from the entities is crucial for the development and training and education of students in these research contests and all this multidisciplinary approach. We have to convince ourselves that these projects are very important for knowledge transfer, and we must continue to procure resources and economic resources so we can have better impacts. So this is some of the recommendations we want to bring to the table so that we can continue advancing in this project so that we can build all the unmanned surface vehicles for the goal ahead. Question in the chat. It says, how was the wind power considered in the Seaflower area? That question will be for Mr. Sergey. We didn't look at the wind energy part. So what I would like to mention here is that in the Caribbean coasts of Colombia, typically on the shores, there are currents that are weaker, given that the wave suffers that dissipation process faster than breaking in a narrow stripe, depending on the bottom relief in the reef barrier. So in the reef environment, we have to find that alternative energy with the breaking of waves and induced currents. Regarding wind energy, is that the best sites in Colombia is like La Guajira, like the area of Bocas de Ceniza. These are very clear areas with very high wind energy that can be used. San Andres, Seaflower is not a site very suitable for this type of contribution. Thank you very much, Mr. Sergey. Unfortunately, we cannot ask any more questions, so we want to thank Mr. Bashir, Mr. Sergey for the presentation, and all the attendees. Please come back at 2 p.m. We will continue with the presentation in the two rooms, respectively. Thank you very much. Have a great day.
Terminando con la jornada de la mañana, hemos tenido un interesante bloque de ponencias que nos permitieron.
So far, we have had a very interesting set of presentations that have shared the concepts for the improvement of shipbuilding and unmanned vehicles, use of alternative energies, among other topics. So we close in this morning presentations. Next, we're going to have a break, and we're going to resume at 2 p.m. to continue with these technical presentations.
En Cotecmar soñamos en grande, navegando a través de la innovación hacia el crecimiento sostenible de la industria naval, marítima y fluvial en Latinoamérica. Esto que nos apasiona ha sido el motor desde hace más de 2 décadas, gracias a la visión estratégica de la Armada de Colombia al crear COTECMAR para hacer soporte clave del mantenimiento y evolución de las capacidades a través del diseño, ingeniería, construcción y mantenimiento de la flota naval colombiana. Desde nuestra privilegiada posición geográfica sobre las aguas cálidas del Mar Caribe en Cartagena de Indias, trabajamos día y los trabajos más retadores, que nos motivan a entregar lo mejor de nosotros con el respaldo y la calidad de nuestro talento humano. Durante todo este tiempo nos hemos mantenido como actor reconocido en el Sistema Nacional de Ciencia, Tecnología e Innovación y liderando el sistema sectorial de innovación de la industria astillera mediante la gestión del conocimiento y ejecución de proyectos innovadores como parte de nuestro ADN y cultura corporativa. Esto nos ha permitido dinamizar nuestra capacidad productiva para ofrecer soluciones integrales con altos estándares de calidad. Contamos con una de las oficinas de diseño e ingeniería más grandes y productivas de la región a través del desarrollo de más de 200 productos innovadores, así como también con un laboratorio de realidad extendida que nos permite asegurar cada paso y detalle durante el proceso de diseño de un buque. Materializamos los sueños de nuestros clientes ajustados a sus necesidades, con la construcción de embarcaciones de defensa, de uso comercial y soluciones tecnológicas de beneficio social. Creemos que un buque siempre debe operar en forma eficiente y segura, y es este el compromiso con nuestros clientes y sus flotas. A través de las operaciones en reparación, mantenimiento y modernización, reflejamos el trabajo seguro, calificado y transparente. Recibimos embarcaciones mayores de armadores nacionales e internacionales para trabajos a flote y en dique mediante nuestro sistema de levante principal, el sincroelevador, lo que convierte a esta maravillosa herramienta en el corazón de las operaciones de nuestra planta de Mamonal. Desde otro lado, sobre la bahía de Cartagena, en nuestra planta de Boca Grande, contamos con un sistema tipo Slipway para brindar soluciones de mantenimiento y modernización a las unidades de la Armada de Colombia y embarcaciones comerciales. Toda esta capacidad instalada y experiencia en el sector astillero también nos permite ofrecer servicios y soluciones ajustados a la industria, convirtiéndonos en un actor clave para el sostenimiento de las empresas industriales en Colombia. Seguimos avante aportando en la generación de empleos, desarrollo de encadenamientos productivos y exportaciones de productos y servicios de alto valor agregado para consolidarnos como líderes innovadores de la industria naval, marítima y fluvial en Latinoamérica. En COTECMAR, seguimos avante.